Hey everybody, this is a compilation of more than 20 hands-on projects from my Python series on YouTube. These projects range in level from absolute beginner to the intermediate level. Feel free to check out additional lessons on my channel. Now, normally I would say sit back, relax, and enjoy the show, but since this is a hands-on based project series, instead I encourage you to lean forward, focus, and get coding. Hey everybody, this is a remake of my Python calculator program for absolute beginners. All you need to know to complete this exercise is just if statements and how they work. So let's get started. For this exercise, a user is going to select an arithmetic operator. Operator equals input. We will ask the user to enter an operator. This will be plus for addition, minus for subtraction, asterisk for multiplication, and a forward slash for division. You could enter more than this, but I don't want to make this exercise too complicated. We will create a variable of num1 to contain our first number. Let's say we would like to add two numbers together. What is the first number going to be? Enter the first number. And let's do this with the second number. num2. Enter the second number. Let me show you something. I'm going to add num1 and num2 together. num1 plus num2. We'll do a test run. Enter an operator. I would like to use addition. Enter the first number. 10 and 11. Well, the result is 1011. When we accept user input, they are string data types. What we've ended up doing is string concatenation. We've concatenated the string of 11 to 10. That's why we ended up with 1011. We'll have to convert these two strings to be floating point numbers by typecasting them as a float. So enclose your input functions with a typecast of float. And now we should be able to add those two numbers together. So let's add 10 and 11. And we get 21.0. Depending on the operator that the user selects, we'll use some if statements to determine that. We will check if our operator variable is equal to a character of plus. And for now, I'll write pass as a placeholder. We'll get back to this later. Else if our operator is equal to minus, we will use subtraction. And for now, I'll write pass. Else if operator is equal to an asterisk for multiplication, we will multiply. Else if our operator is equal to a forward slash for division, we will divide. If our operator is addition, let's create a variable of result. Result equals num1 plus num2. For subtraction, it's going to be num1 minus num2. Multiplication would be num1 times num2. Then division would be num1 divided by num2. Then we just have to print the result. Print our result. Be sure to do this with each of the else if statements as well. And let's see what we have. Let's add 5.5 plus 6.9. That gives us 12.4. Let's subtract 420 minus 0.69. That gives us 419.31. Let's test multiplication. Multiply 3.14 times 3.14, which gives us 9.8596. Then division. Let's divide 69 by 13. And that gives us a really long number. So you could round a number if you would like. We would enclose our result within the round function. And we'll just update each of these print statements. This will round to the nearest whole integer. So let's divide 420 by 13. Let's say that we would like 3 digits after the decimal. Within the round function, we could add comma 3 for 3 decimal places. Enter an operator. Let's use division. Divide 420 by 69. So that gives me 6.087. So we can round to a given digit after a decimal. In this case, 3 places. What if somebody types in an operator that doesn't exist, like the word pizza? Then I will divide 2 numbers. Well, let's add an else statement. If somebody selects some input that is invalid, let's let them know. I'll use an F string. Let's say that the operator that the user has selected is not valid. And let's try this again. Enter an operator. Pizza. Enter the first number, 420 and 69. Pizza is not valid. Let's say is not a valid operator instead. That makes more sense. Pizza will be my operator. First number is 420, second number is 69. Pizza is not a valid operator. Alright everybody, so that is a very simple Python calculator program you can make as a beginner. Hey there, it's me again. In today's topic, we're going to create a weight converter program in Python. This is an exercise that will follow up the lesson on if statements. We'll convert pounds to kilograms or kilograms to pounds. The user is going to decide. We will begin by creating a weight variable. We will assign some user input. Enter your weight. We will convert this input into a floating point number. So add that cast. Then we will ask for a unit. Is this weight in kilograms or pounds? Input, kilograms, or pounds. We want the user to type in either K for kilograms or L for pounds. And these are capital letters, by the way. Using an if statement, let's first check to see if our unit is equal to a capital K. That means the current weight is in kilograms. We need to convert that weight to pounds. Let's reassign weight equal to our weight times 2.205. Else if unit is equal to L, we need to convert to kilograms. Weight equals weight divided by 2.205. Else the user did not type in something that was valid. Let's print, using an F string, unit was not valid. At the end of our program, we will print the new weight. I'll use an F string. Your weight is our new weight after it's reassigned. Now we need a unit of measurement. This is what I'm thinking we'll do. Within our if and else if statements, let's reassign our unit. We're reassigning unit to be LBS for pounds. Else if unit equals KGS for kilograms. In our results, we will display our new unit. Let's take a look. Enter your weight. Actually, I'm just going to make one change. I'm going to add colon space. There, that's much better. Enter your weight. Let's say I'm 180 pounds. This is in pounds. I'll type capital L. Your weight in kilograms is 81.63. I think I'm going to round this. I will enclose the weight variable within a round function. We will round to 1 decimal place. Let's try this again. Enter your weight. Maybe I'm 81 kilograms. I'll type K for kilograms. Your weight is 178.6 pounds. Let's make sure that this else statement works too. Enter your weight. 180 pizzas. Pizzas was not valid. So we're still displaying our output. We would want to avoid that if somebody doesn't type in a valid unit. So let's cut this line, then paste each within the if and else if statements. When we exit the else statement, we're not printing the output. So let's make sure that this works. Enter your weight. I am 180 pizzas. Pizza was not valid. All right, everybody. Well, that is a weight converter program in Python. I thought this would be a helpful exercise now that we have finished the section on if statements. And yeah, that is a weight converter program in Python. Hey everybody, in this topic, we're going to create a temperature conversion program as an exercise. We'll begin by asking what the current unit of measurement is. Unit equals, we'll accept some user input. Is this temperature in Celsius or Fahrenheit? C/F. Then we will ask for the temperature. I'll store the temperature in a variable named temp, meaning temperature. Temp equals input. Enter the temperature. Then we should cast our user input as a floating point number. If unit is equal to C, I'll fill this in momentarily. I'm just going to write pass as a placeholder. Else if unit is equal to F, we will do something else. Else, let's print something, just an error message of some sort. Using an F string, unit is an invalid unit of measurement. Let's test this else statement. Is the temperature in Celsius or Fahrenheit? What if I were to type K for Kelvin? I'll make up some temperature like 100. K is an invalid unit of measurement. All right, we know the else statement works. Let's convert Fahrenheit to Celsius using this formula. We will take our temperature equals 9 times our temp divided by 5 plus 32. I'll take all of this and use the round function. We'll round to 1 decimal place. Then we will print the current temperature in Fahrenheit. I'll use an F string. The temperature in Fahrenheit is our temp variable, degrees Fahrenheit. Let's test this if statement. Is the temperature in Celsius or Fahrenheit? It is currently in Celsius. What is 33 degrees in Celsius converted to Fahrenheit? The temperature in Fahrenheit is 91.4 degrees. All right, so this section is working. Let's work on the else statement. Else, if our unit is currently in Fahrenheit, we'll convert to Celsius. That formula is temp equals our temperature minus 32 times 5 divided by 9. Then I will round the result to 1 decimal place. Then we'll print the temperature in Celsius. The temperature in Celsius is temp degrees C for Celsius. Is the temperature in Celsius or Fahrenheit? It is currently in Fahrenheit. Enter the temperature, 91.4. The temperature in Celsius is 33.0 degrees Celsius. Well, everybody, that is a simple temperature conversion program in Python. I thought we could use some practice with if statements. And in the next video, we're going to create a calculator program. Hey everybody, in this topic we're going to create an email slicer program. I was going to create this program as an exercise at the end of our string indexing video, but I completely forgot, so I'm gonna make a separate video on it. It's a fairly straightforward program. It won't take too many lines of code. Alright, let's begin. We'll accept some user input. We will store this as a variable named email. Email equals input. We'll create a prompt. Enter your email. For my email example, let's say my email is bro123@gmail.com. There is a built-in method of strings called the index function. This function index will return the first instance of a character. Let's find the index of our @ symbol. We'll split the email by username and domain, but we need to know where to split it exactly at this @ symbol. So we will find our index of that @ symbol equals, take our email. Our email is technically a string, so there is a built-in index method. We will find the index of our @ symbol. This method will return a number. We will create two new variables, username as well as domain. Username equals our email. We will use the indexing operator, then place a colon. So where do we begin and end with the username? Well, with Python, we don't need to specify the beginning of a string. You could say 0, but we can omit that. But we do need an ending index, and that would be our index variable. With our domain, we can take the other half of our email. Email, index of operator. Where do we begin and end? Well, we will begin where we left off, index. Index by itself isn't going to work as you would think, and I'll demonstrate why. Then let's print, using an F string, your username is our placeholder, username, and domain is our domain variable. Okay, let's test this. Enter your email, bro123@gmail.com. Feel free to use your own email. Your username is bro123 and domain is @gmail.com. I would like to omit this @ symbol at the beginning of my domain. What we'll do when we assign our domain variable is set the beginning index to index plus 1. Then we will start after the @ symbol. So bro123@gmail.com. Yeah, here we go. Your username is bro123 and domain is gmail.com. If you would like to take less lines of code, here's how. Let's copy this index function, delete our index variable, replace index with that function. So let's test this with a new email. Bro blah 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 123456@gmail.com. That's a very long username. And domain is gmail.com. This style would work as well, however, it's less readable, but it does take less lines of code, so it's up to you how you'd like to write this. It's personal preference. But yeah, I thought that'd be a nice exercise now that we know how string indexing works. And like I said, I forgot to include this exercise at the end of that string indexing video. But a separate video on this topic wouldn't be bad either. But yeah, everybody, that is a email slicing program in Python. Why, hello everybody. In today's video, we'll be creating a compound interest calculator in Python. For those that don't know, interest is a charge for the privilege of borrowing money to some individual or organization. When you place money in a bank account, you typically accrue interest. We'll create a program to tell you what your new balance will be after accruing interest for so many years. But the user is going to decide the initial principal, that's the investment, the rate of interest, and the time in years that this balance has been accruing interest. So let's begin. Let's declare three variables, a principal, a rate, that is rate of interest, and time. Time will be in years. We've recently learned about while loops. I would like to include those within this program, just so we get the hang of using them. We will ask the user to type in an initial principal investment. We will continue to prompt the user to type in a principal that's above 0. Our condition will be while principal is less than or equal to 0. We will take our principal, assign it some user input, enter the principal amount. Then we would like to typecast our input as a floating point number. If our user input principal is less than or equal to 0, we need to inform the user. Principal can't be less than or equal to 0. So I'm going to test my program by printing the principal at the end, just temporarily. Enter the principal amount. I can't type a negative number and continue. What if my investment was negative $1,000? Principal can't be less than or equal to 0. How about 0? Nope, can't do that either. Is 1,000 okay? Yep, 1,000 works. That is for the principal. Let's copy this while loop, paste it, replace principal with rate. This is the rate of interest. Enter the interest rate. Interest rate can't be less than or equal to 0. And let's copy this again, paste it, change rate to time. Let's typecast our input as an integer because we're working with whole years. Enter the time in years. Time can't be less than or equal to 0. I'm going to print my principal, rate, and time. We have principal, rate, time. Okay, we know that principal works. Enter the interest rate. Can my interest rate be -1? No, it can't. Can it be 0? Nope. How about 10%? All right, that works. Time, can time be 0? No, it can't. Can my time be -1? No, it can't. What about 3 years? All right, so we know that our while loops are working. Now here's the formula to calculate interest. Let's say our total, that's our total balance, equals our principal times 1 plus our rate divided by 100. I'm going to enclose this function with a set of parentheses. This portion of our function will take our interest rate, which is a whole number, then create a decimal. Enclose this function within the power function. Raise this function to the power of time. And that is how to calculate compound interest. Then we will print the new balance. I'll use an F string. Balance after our variable time, the word years. I'll add a placeholder. We will add our total. Then I'll include a $sign. Maybe this will be in dollars, but pick any unit of currency you would like. I will format this variable with the format specifier. We will display 2 decimal places, point to F. Okay, let's try this. Enter the principal amount. I invest $1,000 into maybe the stock market. The interest rate is maybe 10% this year. The time in years will be 1. So after 1 year at 10% interest, my new balance is $1,100. Let's try it one more time for good measure. Maybe $500 with an interest rate of 7 over 2 years. Your new balance would be $572.45. All right, now there is another way of writing this program. What if we would like to allow the user to enter in values that are equal to 0, while principal is less than 0? If principal is less than 0, principal can't be less than 0. Let's do that for rate. Interest can't be less than 0. Time can't be less than 0. Here's what happens to our program. Remember that we're declaring our variables at the top. Nothing happens. We go straight to the results. So the reason that this is happening is that when we reach the while loops, this condition is false from the beginning. We never end up entering these while loops. We skip over them because these 3 conditions are all false. We can write a different variation of this while loop where we could say while true. True is a Boolean. That means this while loop will continue forever unless we explicitly break out of the while loop. We're going to add an else clause. Else, we will break. Break will break out of a loop. With our second while loop, change rate is less than 0 to while true. Then we will add an else clause. Else, break out of the loop. While true. Else, break out of the loop. We should be able to enter 0 values in now. Enter the principal amount, 0, 0, 0. Balance after 0 years is $0. This should work the same as before, but we should be allowed to enter in 0 values. $1,000. Interest rate of 0. After 1 year is still $1,000. Well, okay then everybody. I thought that would be an interesting project to create. Now that we know how while loops work, you could write either a standard while loop with a condition, such as principal is less than or equal to 0, or you could say while true. This loop would continue forever. You would need to explicitly break out of the while loop using this break keyword, which we'll cover again in for loops. But yeah, that is a compound interest calculator in Python. What is going on, everybody? In today's topic, we're going to be creating a countdown timer in Python. We'll be using what we learned in the previous topics. Let's begin. We'll need to import the time module. There's a pretty cool function within the time module. That is the sleep function. Type time.sleep, add a set of parentheses. Within the set of parentheses, our program will essentially sleep for a given amount of seconds, like 3. After 3 seconds, let's print something. This is just a demonstration. Time's up. When I execute this code, nothing happens for 3 seconds, but after 3 seconds passes, it displays our message, time's up. So you can use the sleep function of the time module to sleep for a given amount of time. We will ask the user, how long would they like to set the timer for? We will create a variable. Let's say my time. My time will be in seconds. We will create a prompt. Enter the time in seconds. Then we should typecast our input as an integer. We'll need to create a loop. We could use either a while loop or a for loop. There's a lot of overlap where you could use either one. I'll use a for loop in this case. For, we'll need some sort of counter. X in our range 0 through my time. After each iteration, we will sleep for 1 second. Let's test what we have so far. I would like to sleep for 3 seconds. I think that's approximately 3. But now we are going to print whatever X is. Print X. X is our counter. 0, 1, 2. Time's up. We're getting somewhere, but I would like to count backwards. What we could do is enclose our range function within the reversed function. But another technique that we can use is by using a step. Let's replace 0 with my time, then end at 0, but we will set the step to be -1. Then we can increment backwards using this function. That's another technique too, to count backwards. So let's wait for 3 seconds. 3, 2, 1, time's up. Now let's display a digital clock of some sort, but we would have to calculate how many hours, minutes, and seconds there are. So let's calculate seconds. Seconds equals X is our counter, remember, modulus 60. Within our print statement, we'll use an F string. We are displaying hours, minutes, and seconds. I'll add some placeholders for each of these fields. We have seconds. With our digital clock, we can't go above 60 for either seconds or minutes. That's why I'm using modulus 60. The modulus operator gives you the remainder of any division. Let's begin at 11. So 11, 10, 9. So it is counting down, but I would like to add some 0 padding. And we can do that with the format specifier. After seconds, I will add colon. I need to display 2 digits, then 0 pad those digits. Let's try that again. I will wait for 11 seconds, 11, 10, 9. Yeah, and we do have some 0 padding. So that's looking more and more like a digital clock. Let's add minutes then. So to calculate minutes, let's assign variable minutes equal to X divided by 60 because there's 60 seconds within a minute. But then I'm going to typecast the result as an integer. modulus 60. We would not like this field of minutes to go above 60. So let's add a placeholder. We're displaying minutes, format specifier 02. Now I'm going to wait for 65 seconds. That is 1 minute and 5 seconds. Then I just want to be sure that we go below a minute. Yep, it's working. Then let's calculate hours. Oh, by the way, to stop your program from running, hit this red square up in the corner. Let's calculate hours. Hours equals x divided by 3,600. There's 3,600 seconds in an hour. Then we will typecast the result as an integer. Within our f string, we will display hours, format specifier 02. Then I will run this program. Let's wait for 3,605 seconds. That is 1 hour and 5 seconds. And I just want to be sure that we go below 1 hour. Yeah, all right, so that works. So the reason that I didn't add modulus 24, I don't have days within my f string. We can display any amount of hours. I will exclude modulus 24. All right, everybody. Well, I thought that'd be some good practice with working with loops. We should try and do as many exercises as we can. And yeah, that is a countdown timer program in Python. Hello, everybody. Today we will be creating a shopping cart program. This program will be an exercise to follow the previous lesson on lists, sets, and tuples. The more that we practice with those collections, the better we'll be at using them. So I thought we'd create an exercise to get the hang of it before moving on. In this program, we will have 2 lists. Foods. These lists will be empty. We'll declare them but not use them quite yet. And prices. Then a total. Total equals 0. The reason that I'm not using tuples is that tuples are unchangeable. We're going to ask a user what food they would like to buy. We can't append any elements to a tuple. We're not using sets because sets are unordered. I mean, I guess technically you could, but at the end of this program, I'm going to print our shopping cart in order. So I think lists would probably be the best. We have an empty list of foods and an empty list of prices. We'll use a while loop. While true, if our condition is set to true, we'll need some way to break out of the while loop. We'll need a break statement somewhere. We'll get to that later. We will ask the user what food would they like to buy. Let's declare variable food equal to input, enter a food to buy. To exit the while loop, you need to press Q. Q to quit. Then let's check if food is equal to Q, lowercase q, then we will break. We're not done with the program, but let's at least test it. Pizza, hamburger, hot dog, Q to quit. Okay, it looks like it works. Now what if somebody types in uppercase Q? Pizza, hamburger, uppercase Q. Well, we can't actually quit. After accepting our user input, if food dot lower method, this will take our input, make it lowercase, just for a comparison. Let's try that again. Pizza, hamburger. I'll type capital Q to quit, and that is valid. Follow food with the lower method to temporarily make the user input lowercase, just in case they type in capital Q. If the user doesn't want to quit, let's add an else statement. Else, let's take our foods, use the append method, then add whatever food the user typed in. We'll also need a price. Let's ask a user for the price. Price equals input, enter the price of, let's use an f string, a, whatever food the user types in. Pick a unit of currency. I'll pick dollars. We are working with numbers. We should typecast our input as a floating point number, since we're working with prices. So we will accept a price, add our food item to our list of foods, do the same thing with prices. Prices.append whatever the price was. And that is the while loop. Let's test this program again to be sure that everything's working. Pizza. Pizza will be $5.99. Enter a food to buy. Hamburger. Hamburgers will be $3.50. Hot dog. Hot dogs will be $1.75. I would like to quit. I will type either capital Q or lowercase q. Both will work. And we have escaped the while loop. So the while loop is now complete. Outside of the while loop, let's display our shopping cart. Let's print some decorative text. Maybe 5 dashes. Your cart. Then another 5 dashes. I will then iterate over all of the elements found within my foods list. For every food in my list of foods, let's print each food item. Let's take a look so far. Again, we have a pizza. The price was $5.99. Hamburger. The price was $3.50. Hot dog, $1.75. Q to quit. Okay, your cart. That will display the individual list items. If you would rather have these list items arranged horizontally in one line, you can add this keyword, end equals. This end keyword will replace the new line character at the end of a print statement with some other character like a space. Let's try that again. I'll try not to take too much time. Pizza, $5.99. Hamburger, $3.50. Hot dog, $1.75. Q to quit. Yeah, that's much better. We are horizontally listing all of the different items within our list. You could revert back to the vertical list if you'd prefer that. I'll keep my output like this. Then we will need to iterate and add up all the prices. For every price in prices, we do have a total variable that we declared. Let's utilize that. Total equals total plus price. Otherwise, we could shorten this to plus equals price. That would do the same thing. Then we will display the total. Print, I'll use an F string. Your total is, I'll add a unit of currency. I picked the $sign, whatever the total is. Okay, let's run this program one last time. Enter a food to buy. Pizza, which was $5.99. Hamburger, which was $3.50. Hot dogs, they are $1.75. Q to quit. Here's your shopping cart. I'm just going to add one new line real quick, right before we display the total. Just an empty print statement. Here are the results. Your cart. Pizza, hamburger, hot dog. Your total is $11.24. All right, everybody. Well, that is a shopping cart program. I thought this would be a fun exercise to follow the previous lesson on lists, sets, and tuples. And well, yeah, that is a shopping cart program in Python. Hello again, everybody. So today we're going to create a quiz game in Python. Let's declare all of the different collections and variables that we'll need first. We will need a tuple of questions, a 2D tuple of options. My quiz will have 5 questions, but you can add more or less questions. Then a tuple of answers, a list of guesses. We will be appending guesses to our list. That's why we're using a list rather than a tuple. A score variable, which I will set to be 0. Then question number. This variable will keep track of what number question we're on. All right, let's begin with our questions. I have 5. Here are my questions. They're all science related. Feel free to choose your own. This is what I have. How many elements are in the periodic table? Which animal lays the largest eggs? What is the most abundant gas in Earth's atmosphere? How many bones are in the human body? Which planet in the solar system is the hottest? These are the questions, but we'll need options. Let's add 4 options for every question. That's why we're using a 2-dimensional tuple. Each inner tuple will consist of 4 elements. They will be options A, B, C, or D. Let's copy these elements, then paste them within each tuple. This first element corresponds to my first question. How many elements are in the periodic table? I'll come up with some answers. I'll add some answers for the rest of these tuples too. We have a tuple of correct answers. The orders are C, D, A, B. If you come up with your own options, your answers may be different. Now that we have all of our different collections and variables taken care of, let's display each question. I will iterate over our tuple of questions. They are iterable. For every question, in questions, I'm going to print some decorative text. I think that's probably good. Then I will print each question we're iterating over. So let's see what we have so far. There's all 5 questions. After we display every question, I need to display every option. For every option in options. Our options is a 2D tuple. Let's add the index operator. The index is going to be our question number variable. It's a number. So at first, we're accessing options at index of 0, then 1, 2, 3, 4, 5. We will print every option in options at a given row number. Let's test this. Okay, we have some options, but all of these options are for the first question. We will need to increment our question number. So let's do that maybe here. Question number plus equals 1. That is much better. Before iterating the question number, we will ask the user for a guess. Guess equals input, enter A, B, C, D. In case the user types in something that's lowercase, I will follow this input with the upper method to make the user input uppercase. We will take our list of guesses, use the append method, add our guess to that list. If our guess is equal to the answers tuple at index of question number, that means the user guessed the right answer. Let's increase the user score. Score plus equals 1. Then print the word correct. Correct. Else, we will print incorrect. I'll use an F string. Our answers at index of question number is the correct answer. All right, let's answer some of these questions. C, correct. Which animal lays the largest eggs? Definitely the whale, because the whale's the largest creature, right? Incorrect. D is the correct answer. What is the most abundant gas in Earth's atmosphere? Nitrogen. Correct. How many bones are in the human body? D. That is incorrect. A is the right answer. Which planet in the solar system is the hottest? Mercury, because it's closest to the sun, right? Wrong. Incorrect. B is the correct answer. We're keeping track of our answers successfully. Once we complete all the questions, let's print the results. I'm going to add some decorative text. Not necessary, but I think it would look cool. I will display the results. We will iterate over all of the answers and the guesses. Print answers. I'm going to set the ending character to be an empty string. For every answer in answers, print each answer. I will set the ending character to be a space to separate each answer. Then I'll add a new print line. Let's do this with guesses. Change answers to guesses. For every guess in guesses, print each guess. Okay, I'm going to run this again. I'm just going to make up some answers. A, B, C, D, A. Here are the correct answers. Here are the guesses. I guessed none of them right. Then we will print a score. Score equals, take our score, divided by, I'm going to use the length function, then pass in our questions. How many elements are within our questions tuple? Then I will multiply all of this by 100 to give us a percentage. Then typecast this whole formula as an integer. So we're basically just reassigning our score variable. Then let's print, using an F string, your score is our score variable, then add %. I'm going to intentionally get all the answers right. C, D, A, B. Here are the answers. Here are your guesses. Your score is 100%. This time I'll try and get a few incorrect intentionally. C, 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 C. Your score is 20%. All right, everybody. Well, that is a quiz game. Feel free to add more or less questions, or come up with your own questions. And that is a quiz game written in Python. Hey everybody, today we will be creating a program to mimic a concession stand. Much like what you would see at a movie theater. We will be utilizing a dictionary to keep track of a menu item and an associated price. More or less, this is just a program to help us get used to working with dictionaries. Let's begin. We'll create a dictionary named menu. What items are on the menu? We'll need an item and a price. I'll think of some. I'm going to speed up this video. Feel free to pause if you need more time. And here's my menu, everybody. I thought of a few food items you might find at a movie theater concession stand. Pizza, nachos, popcorn, fries, chips, soft pretzels, soda, lemonade. Movie theater popcorn is really expensive for some reason. Okay, we have our menu. A user is going to select specific keys from this menu. Depending on what the key is, we can get the associated value to calculate a total. To keep track of the user selected items, I will create an empty list named cart. I will also declare a variable named total to keep track of the total. We need to lay this dictionary down flat to display it to a user. Well, we do have the items method of a dictionary, which we covered in the last video. For every key value in our dictionary menu dot items method. The items method of our dictionary will return a key and a value during each iteration. I'm simply going to print every key and value. I'll use an F string. I will print every key, colon space, then a value. Let's take a look so far. Here's our menu. I'll make a few changes. The price will be in dollars and cents, but feel free to pick your own unit of currency. I'll precede my value with the $sign. Then using a format specifier, I will display 2 decimal places, 0.2f. That's better. I will line up all the keys. After the key, I will add a format specifier, then allocate 10 spaces. Yeah, look at that. It's all lined up now. Before and after displaying our menu with this for loop, I will add some decorative text. Let's say menu. Then outside of the for loop, I'll display a bunch of dashes. Yeah, look at that. Let's move on to the next step. We will ask a user for some input. What item would they like to buy from the menu? While our condition will be true. If our condition is set to true, we'll need to break out of this loop one way or another. We will ask for some user input. Food equals input, select an item, Q to quit. If food is equal to a lowercase q, then we will break. Let's test it. Select an item. Pizza, nachos, soda, Q to quit. Yeah, it works. Okay, what if the user types in capital Q? Well, we can't escape the while loop. If a user types in capital Q, we're assuming that they would like to quit. When we accept our user input, I'm going to add dot lower method. This will take our user input and make it all lowercase. So we should be able to acknowledge any uppercase letters. Yeah, it works. Cool. Let's add an else if statement. What if a user types in an item that's not on our menu? Well, there is a get method of dictionaries. If menu.get, pass in our food, which is user input. If the user selection is not within our menu as a key, it will return none. So we can use that. Else if menu.getFood is not none, then we would like to append that food item to our cart. Cart.append our food item. So outside of the while loop, I'm going to print our cart temporarily just to test it. Okay, select an item. Pizza, soda, pretzel. How about a potato? Q to quit. We have our pizza, soda, and pretzel, but not our potato. We don't want that in our cart because that's not on the menu. Yeah, you can just add that line. Else if menu item dot get food is not none. That will complete our while loop. Let's calculate a total. For every food in our cart, let's take our total variable, set this equal to total plus, then we need a value associated with a key, plus menu dot get method, get the food item found within our cart. But I'm going to shorten this to total plus equals menu dot get the value associated with this food in our cart. I will also display that food item. Print food. I'm going to avoid printing our food item on every line. I will set the ending character in our print statement just to be a space. Okay, let's see what we have so far. I would like popcorn, soda, pretzel. Q to quit. Popcorn, soda, pretzel. Then we will display the total. I will print a new line. Print I'll use an F string. Total is, add a unit of currency, total. I'll add a format specifier, point to F to display 2 decimal places. I'm going to add 1 line of decorative text. Let's copy maybe this. All right, let's test it out. Select an item. Popcorn, pretzel, soda, potato. Cue to quit. All right, here's our cart. Popcorn, pretzel, soda. We did not include the potato. That was not found within our dictionary. The total is $12.50. Well, there you have it, everybody. That is a concession stand program. The point of this program was to help us get used to working with dictionaries. A dictionary is a collection of key value pairs, such as an item and a price. And yeah, that's a concession stand program in Python. Hey everybody, so today we're going to create a number guessing game using Python. This is a project meant for beginners. By completing this project, it will help us reinforce our understanding of previous topics. Let's begin. We will import the random module. We'll need to pick a random number. The random module is going to handle that for us. What is the range of random numbers for our number guessing game? We'll store those as variables. We will have one variable named lowest number. I'll set that to be 1, as well as a variable for highest number, which I will set to be 100. Feel free to pick a different range if you would like. I'll set the range to be 1 through 100. A random number will be selected between this range, which will be stored within a variable named answer. What is the correct answer? So to choose a random number between these two values, we will access the random module called the randint method. We will choose a random integer between these two values. The two arguments will be lowest num, comma, highest num for the second argument. Let's perform a test run. I will print my answer. The number is going to be between 1 and 100. Okay, we know that that works. Here's a few more variables. We need to keep track of the number of wrong guesses, which I will store as a variable named guesses. We want the user to keep guessing as long as our application is running. We will create a Boolean variable of isRunning, which we will set to be true. Once the user wins the game, we will set isRunning to be false. We will print a welcome message. Let's say Python number guessing game. We will prompt the user. I'll use an F string. Select a number between, I'll add 2 placeholders. Select a number between our lowest number and our highest number. Python number guessing game. Select a number between 1 and 100. Now, if I was to change the range of these variables, that should be reflected. Temporarily, I changed the lowest number to be 10 and the highest number to be 1000. But let's set that back. Between 1 and 100 is good. We'll need a while loop to continue the game each round. We will say while isRunning. Since isRunning is a Boolean, we don't need to say while isRunning equals true. We can just say while isRunning. While this value remains true, continue playing the game. We will ask the user for some input. We will create a local variable of guess. Guess equals, use the input function, then enter a prompt. Enter your guess. There's one thing we want to check. Python number guessing game. Select a number between 1 and 100. Enter your guess. What if somebody doesn't type in a number, like they type in the word pizza? We should let the user know that that's an invalid guess. We'll write the following if statement. If our guess, use the isDigit method. If our guess is a digit, a number, then we will execute any code underneath this if statement. For the time being, I'll write pass. We'll get back to that later. Else, we will do something else. Let's print the following. Print invalid guess. Let's copy this print statement because I'm lazy and I don't feel like typing it out. Please select a number between our lowest number and our highest number. Let's try that again. I will guess pizza, which isn't a number, and we get the message, invalid guess. Please select a number between 1 and 100. All right, that works. Underneath our if statement, we'll write the following. Once we get a guess that is a digit, we need to convert it to a number because when you accept user input, it's a string. We will reassign our guess equal to typecast our guess as an integer. Then increase the number of guesses by 1. Guesses plus equals 1, because we have already made one guess. Here's another scenario. What if somebody guesses a number outside of this range, like 1 kajillion? Well, we should give a warning that that guess isn't valid. If our guess is lower than the lowest number, or our guess is greater than the highest number, we will print the following. That number is out of range. And I will reprompt the user. Please select a number between the lowest number and the highest number. Let's perform a test run. I will guess 1 kajillion. That number is out of range. Please select a number between 1 and 100. We'll add an else if statement. Else if our guess is less than our answer, we will print the following. Too low. Try again. Else if our guess is greater than our answer, we will print too high. Try again. If our guess isn't less than our answer, and our guess isn't greater than our answer, that means we must have the correct answer. Within an else statement, we will print, I'll use an F string, correct. The answer was, insert our answer variable. Then print the number of guesses it took. Number of guesses. Add a placeholder, place in our guesses within the placeholder. Now to escape the while loop, we will take our Boolean variable of isRunning, which is normally true, and set that to be false to escape. And that should be all we need. Let's run this one last time. Python number guessing game. Select a number between 1 and 100. Let's select a number right in the middle, 50. Too low, try again. So the number is between 50 and 100. 75? Too high. It's between 50 and 75 then. 62? Too high. 56? 53. 55. Correct. The answer was 55. Number of guesses. It took me 6. All right, everybody, that is a Python number guessing game you yourself can create as a mini project. Hey everybody, in today's topic, I thought we would create a game of rock, paper, scissors. Now that we know how the random module works, let's begin by importing the random module. We will create some options. We will use a tuple. We're not going to be changing the options, so a tuple would be better than a list. We have 3 options: rock, paper, or scissors. I'll create a variable named player to store the player's choice. For now, I'm going to set this to be none, as well as a computer. Our computer is going to pick a random choice from these options: rock, paper, or scissors. In order to do so, we can use the choice method of the random module. Random.choice. Pick a random choice from options. Let's have the player enter in some input. Enter a choice: rock, paper, scissors. Then we will display the player's choice and the computer's choice. I'll use an F string, player, :space, the variable player. Let's copy that, paste it, then change player to computer. Let's see what we have so far. Enter a choice: rock, paper, scissors. So I pick rock, the computer picks scissors. Let's try it again just for good measure. I pick paper this time. The computer picks scissors. I pick scissors. The computer picks paper. Okay, we know that the computer is successfully picking a random choice from our options. Now, what if the player picks something that's not within this tuple, such as the gun? Well, we would want to stop that, right? We need the user to pick a valid option: only rock, paper, or scissors. I think what we'll do is that when we accept the user input, let's place it within a while loop. So indent this line. While. This condition is going to be kind of weird. While our player variable is not in our tuple options. Let's try this again to see what happens. I pick the gun. Enter a choice. All right, well, if I can't pick a gun, how about a sponge? Well, I can't pick that either. Rock? That works. Our condition is while the player variable is not found within our options. If the player doesn't pick one of these options, this while loop will continue forever. Once we pick something that's within our options, we then escape the while loop. Let's check some win conditions. Now, if the player is equal to computer, that means it's a tie. I will print it's a tie. I'll add a few else if statements. Else if the player is equal to rock, I'll use the AND logical operator, and the computer is equal to scissors. That means you win. Let's print you win. Let's add another condition. Else if the player picks paper and the computer picks rock, then you also win. You win. Else if the player picks scissors and the computer picks paper, then we will print you win. Else, if the player's choice is not the same as the computer's, and we don't meet any win conditions, that must mean we lose. Print you lose. Let's see if this works. Enter a choice: rock, paper, scissors. I pick the gun. Nope, I can't pick that. I pick rock. I pick rock. The computer picks scissors. You win. Let me see if I can lose. I'll pick paper. You win again. Scissors. I need to stop winning. I need to see if the lose condition works. Okay, it's a tie at least, but I need to lose. All right, there we go. I pick rock. The computer picks paper. You lose. What if the user would like to play again? Let's place all of this code within a while loop. Let's do so right about here. Now, I'm not going to write while true like I normally do. This time, I'm going to create a variable. Let's say running. Is our game running? I will set that to be true. While running equals true. Or we could shorten this to just while running. That's simpler. I will place all of this code within the while loop. To mass indent some code, just highlight all of the code, then press tab. Hey everybody, this is Bro from the future. I forgot to explain something. The reason I'm not setting the condition of my while loop to be true is that if you have a lot of code within a while loop, it can be really difficult to find where the break statement is. If I set my condition to be a Boolean variable such as running, it's a lot easier to find any instance where I use this variable. If I were to highlight it, we can see that running is found down here. If I need to change any instance of this variable and rename it to something, you can refactor. Let's rename running as maybe playing. Then I will refactor. So my variable running is now playing, and that change was made down here too. So it's a coding preference. Every time we start a new game, I will reset the player as well as the computer. Let's move these two lines into the while loop at the beginning. So when we start a new game, we will reset the player. The computer will pick a new random choice. So let's see what we have so far. Rock. I pick rock, the computer picks rock. It's a tie. Then we have to play again. So paper, you lose. Scissors, it's a tie. Now what if we would like to escape the while loop? After our win conditions, I'm going to create a temporary variable. Let's name this play again. Then we will ask for some user input. Play again, question mark. Y/n, meaning yes or no. If the user types in something that's capital, I'm going to use the lower method to make it lowercase. So if our play again variable is equal to y, we would like to escape. What I would like to do is I would like to see if the player types in something that's not y. I will precede this condition with the not logical operator. If the user does not want to play again, then let's take our Boolean variable running, normally it's true, and set that to be false. Running equals false. That means we will escape the while loop. Once we escape the while loop, I will print thanks for playing. Now I'm going to change this momentarily. I just want to test it. Rock, play again, yes. Paper, play again, yes. Scissors, you lose, play again. Nope. Thanks for playing. This is entirely optional. I try and create as few variables as possible. I would personally rather avoid creating a variable here. Another way in which I could write this is that I can get rid of this variable. Let's move if not in front of the input and follow our input here, then use the comparison operator. Then add a colon. If the user's input, after making it lowercase, does not equal a y for yes, set running to be false. So that should work the same. Rock, play again, yes. Enter a choice. Paper, play again, no. Thanks for playing. This line would work the same, but it's a little more complex for beginners to read. Or you can use the other method that I showed you. All right, everybody, well, that's a game of rock, paper, scissors. Hello, everybody. Today we will be creating a dice roller program in Python. We will be utilizing some ASCII art. I'll post all of the ASCII art that we'll need in the description of this video. You can copy and paste it to save time if you'd like. All right, let's get started, everybody. We will begin by importing the random module because we will be rolling some random numbers between 1 through 6. If we're going to create some ASCII art, we'll be utilizing Unicode characters. To enter in a Unicode character, it really varies depending on your operating system. I think the easiest way would just be to use Python. To enter a Unicode character, type a /, then a given code for each character. Here are all of the codes that we'll need. After writing these 7 Unicode characters, let's run this program. These symbols that are output, let's copy them. I'll add them to a comment. Then we can delete this line. These are the Unicode characters we'll need to build some ASCII art, some dice. Each die will be made out of 5 lines. Let's begin with the first. We'll need a left corner, 9 dashes, then the right corner. For the second line, copy this vertical bar, add 9 spaces, then a vertical bar. We can copy this whole line, paste it 2 times. Let's use the left bottom corner, add a 9 of these dashes, then the bottom right corner. And here's a basic box shape. Depending on what the number die is, we can add one of these bullet points. For a 1, we can add that right to the middle. So that's good for now. We'll delete this later. Let's create a dictionary. I will name this dictionary Dice Art. Our dictionary is made out of key value pairs. So the keys will be the numbers 1 through 6. Beginning with 1, the value will be a tuple. It's a dictionary made out of key value pairs where the value is a tuple. Within the tuple, let's add these lines, each separated with a comma. I'm going to format these so they form a box shape. Let's take our bullet point, place it right in the middle, then add a comma to the end of this key value pair. That is the first key value pair. Let's copy all of this, paste it again, change 1 to 2. Let's move this bullet point. We need 2 bullet points, about right here and here. Let's repeat this process for keys 3 through 6. Be sure to get rid of the comma at the end. And here is our dictionary of dice art. Each key is a number. Each value is a tuple made of strings. Let's create a list of dice. Our dice will be numbers, randomly generated between 1 and 6. A total, to calculate the total, I'll set that to be 0. Then we will ask a user for a number of dice. This will be some input. How many dice? Then typecast the input as an integer. We don't want somebody to write, 2.5 dice. You can't roll half a die. To generate a random number, you can use the randint method of the random module. We need a random number between 1 and 6. Then we need to append this number to our list of dice. Dice.append. Then we can move this line to within the append method. We need to do this a number of times depending on how many dice the user enters in. We can place this line within a for loop. For every die in our range, number of dice. This will be a number. Let's print our list of dice to see what numbers we have in here. How many dice? I would like 5 dice. 5, 3, 3, 4, 6. Okay, we know that that works. Let's calculate a total. We'll need to iterate and sum all of the elements within our list. We can do that with the for loop. For every die in our list dice, take our total variable plus equals the current value within our dice. Then we will print a total. I'll use an F string, total, colon, space, our total variable. Let's see what we have so far. How many dice? I would like 5 dice. Our total is 19. Now between these two for loops, we will display our ASCII art. The easiest way would be to create some nested for loops. The outer for loop will be in charge of the number of dice. For every die in our range, number of dice. The inner for loop will be in charge of printing every tuple. For every line in, then to get a value in our dictionary, we would type the name of the dictionary, dice art, then use the get method. What are we getting? We're getting a value at a given key. Let's take our list of numbers, dice, at index of die, our counter. Depending on what the user types in for the number of dice, die will begin at 1, then increment. Within the inner for loop, we will print the line. So let's take a look. How many dice? I would like 3 dice. And here's our ASCII art. 6 plus 2 plus 4, that equals 12. If you would prefer, we can display all of these dice on a single horizontal line instead of one vertical line. It's a little more tricky though. If you would prefer that approach, let's turn this chunk of code into comments. We will write this nested loop a little different. So each tuple is made up of 5 elements, right? So if we're printing a horizontal line, let's say we roll the numbers 1 through 3. We would first need to display this line of the first dice, then the first line of the second dice, then the first line of the third dice. During the next iteration of the outer loop, we would display the second line of the first dice, the second line of the second dice, the second line of the third dice. So it's a little more complex. Let's create an outer loop that will iterate 5 times. For every line in range 5. Then the nested loop will be for every die in dice. How many dice do we have within our list? We will print. We're going to get one of the values found at one of the numbers that we roll. Take our dictionary of dice art dot get, then a number 1 through 6. That will be the value found within our list of dice. Get the current die. Remember that this is a number 1 through 6. We would then need one of the elements found within our tuple. So get the first line, then the second line, third, fourth, fifth. So let's add the index operator. Place our counter of line within the index operator. Let's see what we have so far. We need to add one more thing. How many dice? 3. This is an abomination. There's one more change we need to make. At the end of our print statement, let's set the ending character to be an empty string. And that should fix that. How many dice? 3. Okay, we're getting better results. Then when we escape the inner loop, we will print a new line. How many dice? 3. And there we are. 3 plus 6 plus 1 is 10. All right, everybody, so that is a dice roller program. It is kind of complex, but I thought this might be a good exercise. If you would like a copy of this code, I will post all of this in the comments section down below. And well, yeah, that's a dice roller program in Python. Hello, everybody. Today, I'm going to show you how we can write a substitution cipher encryption program. Basically speaking, what we're going to do is that we have a message. To hide the message, we can encrypt it by replacing every instance of one character with another, chosen at random. Using the same key, we can then decrypt the message. When I was at my university, I took an Intro to Cybersecurity course. I turned this program in as a final assignment, and I did get an A on it. I don't know, maybe it'll help you. At the very least, it's a good exercise. All right, let's get started, everybody. We will begin by importing the random module, as well as the string module. Let's create a string of characters named chars. Whatever characters you would like to use for your encryption program, list them here as a string. However, this can be a lot to write. I think a better solution would be to import some constants from the string module. I'm going to include some punctuation. I will import the punctuation constant of the string module. How the heck do you spell punctuation? Okay, that's right. Plus, I will add some digits. String dot digits constant plus string dot ASCII letters. Let's take a look at our characters so far. We have one long string of characters. What if I would like to include a space, a white space? Well, there is a constant for that, but that includes things like carriage return. That's going to warp our results. Let me show you just for a demonstration. String dot white space plus all the other stuff. We have a carriage return and some other characters. I would like to avoid that, so in place of importing the white space constant from the string module, I'm going to add a space character. That's good enough. Here are all the characters I will be using this program. Feel free to add more or less. This is all one long string. I'm going to turn the string into a list, where each character is an individual element. To do that, I'm going to take our string of chars, reassign it, then typecast my string of characters as a list. Then let's print it again. Print chars. Instead of one long string, we have a list of all the characters we'll need. I am then going to create a key, which we will shuffle eventually. Key. Then to create a copy of a list, you can type the original list dot copy method. Then I will print my key. I'm going to place these lists within an F string. Chars then key. Let's see what we have. We have two identical lists, one for the original characters and the other for the key. We're going to shuffle this key. Random.shuffle, pass in our list of key. Look at that, all of the characters are now shuffled in a random order. What we'll be doing when somebody types in some text to be encrypted, we will replace every instance of one character within that string, let's say an O, then replace it with another one. Every time we run this program, this key will be reshuffled. Let's ask for some user input. This part of our program, we will do some encryption. Plain text is the original message. Plain text equals, we will accept some user input, enter a message to encrypt. Ciphertext is the name of the encrypted message. That will be an empty string. Okay, let's say a user types in a message. Enter a message to encrypt. I like pizza. It's a very important message. Every instance of a character within my plain text, I will refer to the key and replace that letter with a different one. For example, any Z's, I have two Z's in this program, will be replaced with, let's see, capital B. Every time we run this program, though, it's going to shuffle the key, so it's not going to be consistent. What we're going to be doing is iterating over every letter in our plain text. For every letter in plain text. Strings are iterable. Find the index of every letter from our plain text within our list of characters. Let's assign a variable index. Index equals, take our list of chars, use the index method. We are looking for that letter, whatever letter we're currently on. Then return an index. Then refer to our key, get whatever letter is at that same index. So we will append that to our ciphertext. It's currently an empty string. Ciphertext plus equals our key at the given index. Our ciphertext should be the encrypted message now. Let's print it out. Print, I'll use an F string. Original message. Let's print our plain text. Then our encrypted message. Print our ciphertext string. Let's take a look so far. Enter a message to encrypt. I like pizza. Then here's the new encrypted message. Every instance of a character within my plain text was replaced with another. So for example, any Z's were replaced with E. I have two E's within this encrypted message. If I were to run this program again, it would likely be different. I like pizza. And here's my new encrypted message. My Z's were replaced with semicolons this time. For every letter in our plain text, get the index of each letter, then refer to the key, add the new character to our encrypted message. It's probably best for us not to display the characters and the key, so let's hide those. We will be reusing this key for decryption. Now to decrypt the message, let's copy this section of code, paste it. We are now decrypting. We will ask for some ciphertext, then reset our plain text. For every letter in our ciphertext, refer to our key, append a character to our plain text. Within our list chars at a given index. We will display our encrypted message, followed by the original message. Let's try it one last time. Enter a message to encrypt. I like tacos. Here's my original message, then the encrypted message. If I were to decrypt the encrypted message, it should give me my original message. I will type in these characters exactly. Hit enter. And here is my message decrypted. I like tacos. All right, everybody, so that is a substitution cipher encryption program for beginners. When I was at university, I did turn this program in for a final assignment for a cybersecurity class, and I did get an A on it, so maybe it'll help you. And well, yeah, that's an encryption program for beginners in Python. Hey everybody, in today's topic, we'll be creating a credit card validator program in Python. It sounds intimidating, but it's actually not that bad. Oh, I almost forgot. If you need a credit card number to work with, you can always look online for test credit card account numbers. I've listed the steps here. After accepting some user input, what we'll need to do is remove any dashes or spaces that the user may enter in. To check if this number is valid, we will add all digits in the odd places from right to left. Then we will double every second digit from right to left. All of the even numbers, basically. If the digit doubled is now a 2-digit number, add the 2-digit numbers together to get a single digit. After doubling all your even digits, add them together to create a sum of even numbers. Sum the totals of steps 2 and 3. If the sum is divisible by 10, the credit card number is valid. We'll tackle this program step by step. Let's declare all of the variables we'll need throughout our program. We'll need to hold the sum of all the odd digits from right to left. I'll store that within a variable named sum odd digits. I'll set that equal to be 0. Then we will sum the even digits. I'll set that to be 0 as well. Then I will declare a variable named total to store the total. All right, now let's begin with step 1. I'll just add a comment. Step 1. We will accept some user input. We'll store that within a variable named card number equals input. We'll ask the user to enter a credit card number. We're not going to typecast this number. We will keep the user input as a string, for now at least. we'll need to remove any dashes. We can do that by reassigning our card number equal to card number, then use the built-in replace method of a string. We will replace any dashes with an empty string. Just temporarily, I'm going to print our card number just to be sure that we remove the dashes before continuing. So enter a credit card number. I'm just going to make up a number, 1234-5678-9012-3456. Yep, and all the dashes have been removed. Now, if the user types in any spaces to separate each of the 4 digits, let's remove those too. We will reassign card number equal to card number, use the built-in replace method, replace any spaces with an empty string. Let's try this again. I'll enter in my card number, but separate each group of 4 digits with a space. All of the spaces are gone. Now with the following steps, we're going to be summing the digits from right to left. I think the easiest way to do this is to reverse our string. And that's fairly simple in Python. We will take our card number, reassign it equal to card number, use the indexing operator. There's going to be no beginning index or ending index, but we will set the step to be -1. This will reverse our string and reassign it. Let's test it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6. Yeah, and our string is now reversed. So that completes step 1. We no longer need to print our card number. We will move on to step 2. Step 2 states that we need to add all digits in the odd places from right to left. Well, a string is iterable. We can use it within a for loop. For x in our card number, we will need every second digit. There's no beginning index or ending index, but we will set the step to be 2. We will iterate over every second digit within our card number. X will store each digit temporarily. So we will take our variable sum odd digits equals sum odd digits plus x. But we can simplify this to sum odd digits plus equals x. There's one more thing we need to do for step 2. I'll demonstrate. Let's type in our credit card number. I'm just making up a number again. So we have an unsupported operand type. We're iterating over a string. X is technically a string. We would want to typecast x as an integer. Let's try that again, just to be sure everything works fine. Okay, yeah, there's no problems. That will complete step 2. Let's move on to step 3. Step 3 states that we will double every second digit from right to left. If the result is a 2-digit number, add the 2-digit number together to get a single digit. With the for loop, for x in our card number, we will iterate over every second digit. Set the step to be 2. However, we will begin at the second digit, which has an index of 1. X will store the current digit. Let's reassign x to be x times 2, because we're doubling every second digit. However, we would need to typecast x as an integer, because it's currently a string. To see if x is a 2-digit number, we can easily use an if statement. If x is greater than or equal to 10. If x is greater than or equal to 10, it should technically be a 2-digit number, right? Because 10 is a 2-digit number. So if x is a 2-digit number, we'll need to split that number, then add them together. Let's take sum even digits plus equals x modulus 10. That would give you the remainder of any division. Then add 1. The largest that x can be in this scenario is 18, because the largest a single digit can be is 9 in our credit card number. So 9 times 2 is 18. 18 modulus 10 would give us 8. We would split that number to get 1 and 8. then add those two numbers together to get 9. So else x must be less than 10. If that's the case, we would take some even digits plus equals whatever x is. That completes step 3. Let's move on to step 4. Add together both the sum of the odd digits and sum of the even digits. Total equals some odd digits plus some even digits. Then step 5. Step 5. If our total is divisible by 10, it's a valid number. If total modulus 10 is equal to 0, then print valid. Else print invalid. And that should complete our program. Let's test it. Enter a credit card number. I'm just going to make up something. So this is an invalid number. For a valid number, you can either use your own credit card, if you have one, or you could find a sample online. I'll just use the first one that I find. Oh yeah, that number is valid. Just for good measure, I'll test another. Yep, that one is also valid. Alright everybody, I thought this would be a good project for us to work on. It helps us get used to working with strings and loops as well. But yeah, that is a credit card validator program in Python. Hey, what's going on everybody? So in this video, we're going to create a very simple banking program using Python. This is meant to be more of an exercise to get us used to working with functions. When creating a project, I like to divide that project into smaller sections, then handle them one at a time. So we'll do that by declaring all the functions we'll need first. With the banking program, we'll need to show a user their balance. We'll define a function to show balance. For the time being, I'll write pass just as a placeholder. We'll need to make a deposit, define deposit, make a withdrawal, define withdraw. Near the end of this project, we will be creating a main function and placing the main body of our code within it. We'll handle that near the end, just to contain everything. We have our 3 functions. With our banking program, we'll need to show a balance, make a deposit, or make a withdrawal. What are some variables we'll need? Well, we'll need a balance, which I will set to be 0 initially. I will also create a boolean of is running. This will be true. If at any time we set is running to be false, we'll exit the program. So with the majority of our code, we'll place it within a while loop. While is running. You can check to see if this is equal to true, but since this is a boolean, that's not necessary. We will just say while is running. If is running becomes false, we'll exit the while loop. Within our while loop, we'll print some sort of welcome message. Let's print banking program, then list some options. Let's print 1, show balance. 2, deposit. 3 will be withdraw. 4 will be exit. Afterwards, we will set a choice variable to equal some user input. Input. Enter your choice 1 through 4. We're encouraging a user to type in a number 1 through 4 to select an option. Do they want to show their balance, make a deposit, make a withdrawal, or exit? We'll add a few if and else if statements. Let's check to see if the user's choice is equal to 1. And that is a string of 1. Our user input is a string data type, unless we were to typecast it to something else. If our choice is equal to 1, we will call the function to show balance. Else if our choice is equal to 2, we will make a deposit by calling the deposit function. Else if choice is equal to 3, we will call the withdraw function. Else if choice is equal to 4, that means we would like to exit. So we need to exit this while loop. We can do that by setting our variable of is running, is this program running, equal to be false to exit. If somebody types in some input that's not valid, we can handle that with an else statement. Else, let's print that is not a valid choice. Okay, let's see what we're working with currently to test everything. We haven't written anything within these functions yet, show balance, deposit, or withdraw. So we can type 1, 2, 3, and 4 to exit. Processed finished with exit code 0. So we can exit the program, we just have to select option 4. With this else statement, this will execute if we type in something besides the numbers 1 through 4, because there's no other options left. So to test that, enter your choice 1 through 4. I'm just going to type the word poo. That is not a valid choice. So we know that the else statement is working. Once we exit the while loop, let's print a message that says, "Thank you, have a nice day." If I was to type 4 to exit, we should exit the program. Thank you, have a nice day. Let's make that H capital. Now we'll work on our functions, beginning with show balance. Currently these two variables are global. We don't need to pass them as a parameter to these functions quite yet. We will be enclosing all of this code within a main function. We'll handle that later though. So with show balance, all we're going to do is print, I'll use an F string. Your balance is, add a $, or other unit of currency of your choosing, add a placeholder, our balance variable, and let's see what we have. I will type 1 to show balance. Your balance is $0. I'll display our balance with 2 decimal places after. I will add a format specifier after balance, colon, point to F will add 2 decimal places. We covered format specifiers in a previous topic. So if I were to run this again, type 1, we show $0 and 0 cents. We're displaying 2 floating point decimal places. Now we need to make a deposit. That'll be the next function. We will define a local variable of amount equals accept some user input. Enter an amount to be deposited. Again, when we accept user input, it's a string. We'll typecast it to a number, a floating point number, because we have to include dollars and cents. We'll add some checks, though, after accepting some user input. If our amount is greater than 0, we don't want anybody to make a negative deposit. Let's print, that's not a valid amount. Else, we are going to return our amount. So this function is going to return something. So within our else if statement, we will take our balance plus equals the deposit we're being returned with. This will add our deposit to our balance. Balance plus equals deposit. Let's try it. Let's show our balance. Our balance is $0. We'll make a deposit of $100 exactly. Again, we'll show our balance after making the deposit. Your balance is $100. Let's attempt to deposit negative money. We'll select 2 to make a deposit. We'll deposit negative $420.69. That's not a valid amount. So we have a problem. We have a type error. Unsupported operand for float and none type. So within this statement, within if, within our deposit function, we're not returning anything. Let's just return 0. We have to return something. And within this if statement, we didn't return anything previously. We'll either return 0 or return a valid amount. Let's try this again. Let's make a deposit. I will attempt to deposit negative $420.69. That's not a valid amount. Our program's not crashing. That's good. Now we'll attempt to make a valid deposit. $50.01. Then show my balance. Your balance is $50.01. Okay, that is the deposit function. We'll work on the withdraw function next. We will create a local variable of amount, accept some user input, enter amount to be withdrawn. Our user input is going to be a string. We will typecast it to be a floating point number. We need to check to see if our amount we're trying to withdraw is greater than our balance. Users shouldn't be able to withdraw more money than what they have in their bank account. If the amount is greater than our balance that we have, we will print insufficient funds. Else if the amount somebody's trying to withdraw is less than 0, we will print a different message. Amount must be greater than 0. Else we will return our valid amount. So with our if and else if statements, we do need to return something. If we take one of these routes, we will return 0. We're not making any changes. Within our else if statement, where we select choice 3, we're going to take our balance minus equals the withdraw amount. Let's test this. Banking program. Let's show our balance. Our balance is 0. We'll make a deposit of $100. Show my balance again. Your balance is $100. Let's press 3 to withdraw money. Enter amount to be withdrawn. $1 cajillion. Insufficient funds. Yeah, no kidding. Let's attempt to withdraw money again. We shouldn't be able to select a negative amount. Negative $420.69. Amount must be greater than 0. Let's enter in a valid number this time. I would like to withdraw $49.99. That has appeared to work. We'll show our balance again. Your balance is now $50.01. Then we can exit by pressing 4 to exit. Thank you and have a nice day. The last few changes I'm going to make is that I'm going to enclose all of this code, our main portion of code, within a main function, just to encapsulate all of our variables and help with readability. We will define a function of main. Take all of our code within the main body of our program and place it within the function. I'm just going to select all of it and indent it. At the end of our program, we need to call a main function to run it. If you're familiar with the statement of if dunder name is equal to a string of dunder main, that means this program can be imported or run standalone. It is good practice to include this if statement. We discussed this in the previous video. If we're running this program directly, execute the main function. However, our variables of balance and is running, they're now enclosed within this local scope. These other functions have no idea what these variables are of balance. So we need to pass in our balance to those functions of withdraw and show balance. When we show our balance, we have to pass in our variable of balance. Same thing with withdraw. Then set up those parameters. Within show balance, we will have one parameter of balance. The same thing with withdraw. The last thing I'm going to do is add a little bit of text decoration around my program, just to make it look nice. So I will print a bunch of asterisks. It's not necessary, but I think it'll look nice. Let's add some text decoration before and after the title of banking program. Also before our choice. Basically, whenever we print anything, we'll add some text decoration. Let's do that with show balance. Our deposit. And within withdraw. Okay, let's run this one last time. Banking program. Let's show our balance. Your balance is $0. We'll make a deposit. $100.01. Show our balance again. Your balance is $100.01. We will withdraw money. Enter an amount to be withdrawn. $1,000. Insufficient funds. Let's try that again. Let's withdraw $50. Show our balance again, $50.01. Then press 4 to exit. Thank you and have a nice day. Alright everybody, that is a simple banking program you can write using Python. Hey everybody, in today's video we're going to create a beginner's slot machine program using Python. This project's meant for beginners, so let's get started. When creating a project, I like to break up that project into different sections, then tackle them one at a time. So with the slot machine, what are some of the different functions we'll need? Well, we'll need to spin a row. We'll define a function to spin row. As a placeholder, I'll write pass. We'll return to this function later. We need to display or print the row. Print row. If somebody gets matching symbols on the slot machine, we need to give them a payout. We'll create a function to get payout. In this function, we'll calculate what that payout is going to be. But again, we'll get to that later. We'll write the majority of our code within a main function. At the end of this program, I will add the if statement of if dunder name is equal to a string of dunder main. Then we will call the main function, which drives our code. This program can be imported or stand alone. It is good practice to add this if statement. A majority of the code we're going to write is going to be within our main function. So within our main function, let's declare the variables we'll need throughout this program. We will need a starting balance, which I will just name balance. We will start with 100, as in $100. We'll need to display some sort of welcome message. Let's print something. We will print welcome to, let's name our game Python Slots. Just for some flavor, I'm going to add some text decoration. Just a bunch of asterisks. I think it'll look cool, but you don't have to. Let's display our symbols we're going to use. Symbols. I'll add some emojis. We'll use emojis in this program in place of images. If you're on Windows, you can hold down the window key plus semicolon. Let's add a cherry. You typically see a lot of fruit in slot machines. A watermelon. A lemon. There's also a lot of bells for some reason, but we'll add those. And a star. Let me just align everything. Let's do a test run. Welcome to Python Slots. Let me make one adjustment. Okay, I'm happy with that. So after our welcome message, we'll continue playing this game while our balance is greater than 0. While we still have money, we can continue playing. We will print, I'll use an F string, current balance, colon space, I'll add a placeholder, pick a unit of currency, I'll pick American dollars. Then we will display the user's balance. We will prompt the user to enter in their bet, which we will assign to a variable of bet. So input, place your bet amount. Let's do a test run. Welcome to Python Slots. Current balance, $100. Place your bet amount. We won't deduce the bet amount from the balance quite yet. I just want to be sure that we can enter in something. $1. Good. $10. $100. What if somebody types in a word like pizza? We need to prevent that input and correct it. We'll check if, take our bet, use the isDigit method. Is our bet a digit? If somebody types in a word like pizza, we need to tell them that's not valid. So this will return true if our bet is a digit, but we're going to use the not logical operator. If our bet is not a digit, then do this. We will print, please enter a valid number, followed by the continue keyword. The continue keyword will skip the current iteration of this loop and start from the beginning. Let's test it. Place your bet amount. Pizza. Please enter a valid number. So we have our current balance again. Place your bet amount. I'll type in 1. Okay, we did not get that message of please enter a valid number. This bet of $1 is valid. So if our bet is a digit, we'll convert it to be an integer using typecasting, because when you accept user input, it's a string. It has the string data type. Let's reassign our bet, typecast our bet as an integer. Then we will check to see if our bet is greater than our balance. People can't bet money that they don't have. If the bet is greater than the current balance, if bet is greater than balance, we will print this message instead. Insufficient funds. Then continue. If somebody tries to bet negative money or no money, we'll add this statement. If bet is less than or equal to 0, we will print bet must be greater than 0, and continue. If all these checks pass, if our bet is not a digit, if our bet is greater than our balance, or if our bet is greater than 0, we will take our original balance minus equals our bet to subtract it. Let's do a test run. Place your bet amount. Pizza. Please enter a valid number. I will bet $1 kajillion. Insufficient funds. Yeah, no kidding. $0. Bet must be greater than 0. What about $1? Our bet should be subtracted from our balance. Let's try 10. We are now down to 89. Let's bet $90. Insufficient funds. 89. And that has appeared to work. Once we subtract our bet from our balance, we will call the function toSpinRow. This function is going to return a list, which we will assign to be row. Row will be a list. Using the spinRow function, we have to generate 3 random symbols, then return them within a list. We'll work on the spinRow function next. Within our spinRow function, we will declare a list of symbols. Add your symbols. but these need to be strings. Make sure they're all comma separated. There we go. This is where list comprehensions can come in. If you don't know what a list comprehension is, here's an alternative. We will declare an empty list of results. This is an empty list. We need a for loop to generate 3 random symbols. We could say for symbol in range 3. This for loop will iterate 3 times. During each iteration, let's take our empty list of results, use the append method. We will append a random.choice among our symbols. So we need to import the random module. We'll do so at the top. Import random. We're telling the random module to pick a random choice from this list of symbols. Then we will append them to our empty list of results. After we escape the for loop, we will return our results. It's a list. Now, a much better option is to use a list comprehension. Here's how. It's going to be a lot more concise. We will return a list. Within the list, we will write a list comprehension. For every, let's say, symbol in range 3, there is no condition. What do we want to return during each iteration? Access the random module, use the choice method, then pass in our symbols. Symbol isn't used in this example. What you may see people do is use an underscore as a placeholder. Basically what we're saying is for every iteration in range 3, return a random symbol. That's all we need for the spin row function. Going back, we have our list of row. Afterwards, I am going to print it to test it. Print row. And we should have 3 random symbols after making a bet. All right, it looks like it's working. We'll make a few changes though. Instead of printing our row, I'm going to print the word spinning. I will add a new line character just to give us some space, like after this word of spinning. Then we will call the print row function. We'll pass in one argument, our row. That's returned to us after we spin the row. So going to our print row function, we need to set up one parameter, our row that we receive. It's going to be a list. One easy way to print the elements of a list is that we can pick some sort of separator for each item in the list. For example, I'll just print a space. With strings, there are built-in methods. We will use the join method, then pass in our list, or other iterable. Basically what we're saying, using the join method, we're going to take our iterable, in this case our list, join each element by a space character. Here's the result. We have 3 symbols. You could join them by a different character. I'll add a vertical bar. Enter your bet amount, $1. Now we have a vertical bar between each of these symbols. We could include more than one character. I'll add a space before and after this vertical bar, just to space things out. I think that looks a lot better. And you don't have to, but I'm going to add some text decoration before and after. I'll add a bunch of asterisks. Let's see what we're working with. Not bad. So every time we make a bet, we get a new set of symbols. Now, what if all 3 symbols match? We need to calculate a payout and give it to the user, because, well, they won. So after we print our row, we will call the get payout function, but we will pass in our row, it's a list, and our bet. How much did we bet? we will be returned with a payout, which we will add to our balance. Let's go to the getPayout function. We're sending two arguments to our getPayout function, a row and a bet. We have to check to see if each element in our row is all the same. Is it all the same character? We can do that with an if statement. If our row at index of 0, that's going to be the first symbol, is equal to row at index 1, that's the second symbol, is equal to row at the second index, and that's the third symbol. If all three symbols match, we have to return the bet multiplied. Within our if statement, we will add another if statement. I will check to see if our row at index 0 is equal to our first symbol of cherry. Be sure to place it within quotes because it's a string. Now the reason I'm only checking if row at index 0 is a cherry emoji, all these symbols are going to be the same. If we're within this if statement, all of these symbols are going to match. We only need to check one of them. It could be 0, 1, or 2. But I'll just add 0. They're all going to be the same regardless. If somebody has all cherries, we will return their bet times 3. Or some other amount. You can make the payouts higher or lower. Else if row at index 0 is equal to a watermelon, then we will return their bet times 4. So watermelons are worth more than cherries. Else if row at index 0 is equal to a lemon, we will return their bet times 5. Else if row at index 0 is equal to a bell, let's give them times 10. Return bet times 10. Else if row at index 0 is equal to a star, that's worth the most, we will return their bet times 20. Make sure we're not within our if statement anymore. If all three symbols don't match within our list, we don't want to give the user anything. They lost that spin. We will return 0. That's all we need for the getPayout function. Scrolling back down, after receiving a payout, it's returned to us from this function. We'll check to see if our payout is greater than 0. That means they want a spin. I will print, I'll use an F string, U1, I'll add a placeholder, precede this with a unit of currency, I'll use dollars, we'll display the payout. Else, if they did not receive a payout, that means they lost that spin. We will print, sorry, you lost this round. Then take our balance, this is our original balance, plus equals our payout. In most cases, the payout is going to be 0, but if the user wins something, we will add that to the balance. Okay, let's do a test run. I will bet $1. Sorry you lost this round. And my current balance is 99. Let's bet again. I'll just keep on doing this until I win. We're going to lose more times than what we win. Okay, see, I got all bells. It says you won $10. Once somebody runs out of money, we want to stop them from playing, or if they would like to exit. We'll create a variable of play again. We will accept some user input. Do you want to spin again? We'll add y for yes / n for no. If our variable of play again does not equal a character of capital Y, then we will break to break out of this loop. Let's do a test run. Enter your bet amount. I'll just bet $1. Do you want to spin again? If I type in anything besides a capital Y, we will exit. I will type in no. Then we exit. Enter your bet amount. I'll bet $1. If somebody were to type in a lowercase y, that doesn't register. We'll make it uppercase by following our input with the upper method to make it uppercase. Place your bet, $1. Hey, I won. I won $3. Do you want to play again? I'll type in a lowercase y. Yes, I would like to play again, but I did not hold shift in order to make this a capital Y. That will still register. And our current balance is $102. We're ahead currently. Place your bet amount. I'll bet $10. We lost this round. I will press N because I don't want to play again. Then we exit. So at the end of our program, I will print, I'll use an F string, game over. Your final balance is, I'll add a placeholder, pick a unit of currency, I'll pick dollars, display our balance. Then I'll just add some text decoration before and after to make it all look nice. Okay, let's play this one last time. Enter your bet amount. I'll bet $1. Sorry, you lost this round. Do you want to spin again? Yes, I do. I will bet $5. You lost. Spin again. Yes, I will bet 10. 20. Again, I'll bet 20. I keep losing. I'm running out of money, guys. Hey, I won $10, though. Do you want to spin again? No. Game over. Your final balance is $13. That's why you shouldn't gamble. You tend to lose more money than what you gain. Alright everybody, so that is a slot machine program you can write using Python. What's up everybody? So in today's video, we're going to create a game of Hangman using Python. I thought that this would be a good mini project for us. While learning to code, it is important to create small projects as you go along. Here's one that we can make together. When creating a project, I like to declare the various variables and data structures I'll need first, followed by the functions I'll need. For this game, we will need a set of words. One of these words is going to be chosen at random. So let's create a few words. I'll add some fruit. Apple, orange, banana, coconut, and one more. Pineapple. Using the random module, let's import that. Import random. Using the random module, we will pick one of these words at random. We won't be able to see what it is, but we can guess what the word is, one letter at a time. Once we reach 6 incorrect guesses, we lose the game. Before each guess, we will display some ASCII art, which I will name as hangman art. This will be a dictionary where each key value pair contains a tuple. So this is a dictionary of, we'll have a key, which will be a number, and a tuple. The key is going to represent the incorrect number of guesses. So we'll start at 0, we will display a tuple, which will contain some ASCII art. Then let me just copy this. For one incorrect guess, we'll display some different ASCII art. I'll just put each on a new line for readability. So we're going to go all the way up to 6. Once we hit 6 incorrect guesses, we lose the game. Each key corresponds to the number of incorrect guesses. Once we reach 6, we lose the game. Each tuple that corresponds to the incorrect number of guesses, we will display a certain image. If you would like, feel free to look in the description of this video if you would like to copy this to save you some time. Each tuple will consist of 3 rows, 3 strings. For no incorrect guesses, where incorrect guesses is 0, we will display nothing. We can't see our hangman person. For one incorrect guess, we will display their head. For 2 incorrect guesses, we will display their head and the main torso of their body, which we'll represent with a vertical bar. Let me copy this one. For 3 incorrect guesses, we will display their left arm, represented with the forward slash. With 4 incorrect guesses, we will display their right arm. However, if you use a backslash, that's an escape sequence within a string, you have to use double backslashes to literally print a backslash. So with 5 incorrect guesses, we will display their left leg of the person. Then once we reach 6 incorrect guesses, we display the full person. That's when we lose the game, when we see the entire person. That's some ASCII art that we can use. So let's test it just to be sure that everything is working fine. I will print my hangman art at the key of 0 to represent no incorrect guesses. Okay, so when we display this person, we're going to have to use some sort of loop. For every, let's say, line in hangman art at index of 0 for 0 incorrect guesses, I will print each line. With no incorrect guesses, we don't display anything. That's correct. We can't see the person, and that's okay. So with 1 incorrect guess, display the dictionary where the key is 1. That displays the person's head. 2 would be the main torso of their body. 3, their left arm. 4, their right arm. 5, their left leg. And 6, their right leg. Once we see the entire person, we lose the game. So we can delete these 2 lines of code. We no longer need them. We know that our dictionary is working. I'm going to zoom out a little bit. Following our dictionary, we'll declare the various functions we'll need throughout this program. We will define a function to display man, our hangman. There will be 1 parameter, wrong guesses. And then for the time being, I'll write pass. We'll fill in this function later. When we display our man, we need to know the number of incorrect guesses to display the right image. We have a display man function and a display hint function. We will have a string of hint. Then I'll write pass for now. Our hint is going to be a list of underscore characters. For each letter that we guess right, we'll flip one of those underscores to be a letter, if that letter is correct. I'll create a function of display answer. Within this function, we will display the correct answer, either when we lose the game or win the game. And I will write pass. We will create a function of main to contain the main body of code of our program. Again, I'll write pass for now. I'll add the following if statement. If dunder name is equal to a string of dunder main. If we are running this file directly, I would like to call the main function to start the program. Alright, let me zoom out. This will be the main skeletal structure of our program. Import the random module. We have our set of words. We'll be importing more from a separate file near the end of this video. We have a dictionary where the key is a number to represent the number of incorrect guesses, and a tuple to display some ASCII art. We have 4 functions: display our man, display the hint, display the answer, and the main function to contain the main body of code. Alright, let's work within our main function. Within our main function, we will create a variable of answer. What is the correct answer that we have to guess? I will access the random module, call the method of choice, then pass in our set of words. One of these words will be chosen at random. Let's test that. I will print our answer, just temporarily. We should get a random word. Apple, apple, pineapple, apple. I guess it really likes apple for some reason. There we go, we have orange. We are choosing a word at random. We no longer need this print statement. Looks like everything is working fine. Now we'll display our hint. Our hint is going to be a list of underscore characters. I need the number of underscore characters to equal the number of characters in one of these words that is chosen at random. So I could multiply my list by the length using the length function of my answer. So let's print our hint to see what we're working with. With my selected word, we have how many underscores? 1, 2, 3, 4, 5, 6, 7. Okay, we have a different word. 1, 2, 3, 4, 5. That is probably apple. It has 5 characters. All right, so that's our hint. It's a list of underscore characters. When we guess a letter, if it's correct, we'll fill in one of the underscores with that correct character. We need to keep track of the number of wrong guesses. We'll create a variable of wrong guesses. Set that equal to be 0 when we start the game. We're going to keep track of all of the incorrect guesses that we've made. We will create a set of guessed letters. For an empty set, we'll call the set function. Normally in Python, you can't create an empty set with just a set of parentheses. We have to use the set function. Then I will create a Boolean variable of isRunning. Set that to be true. While our game is running, continue playing. Once we lose or win the game, we will switch this to be false to exit the game. We will keep this as true when we initially run this program. After we declare the variables we'll need within the main function, we'll create a loop, a while loop. While is running. We don't need to say while is running is equal to true. We don't necessarily need to create that comparison. We can just say while is running. While this is true, continue doing some code. So what would we like to do? Let's call the function of displayMan, but we have to pass in the wrong number of guesses. Call our function of displayMan, pass in our variable of wrong guesses. When we begin the game, we would like to display one of these images. Then we will display our hint. Then we'll call the function to display our hint. Pass in our hint. That was the list of underscore characters to represent the answer we have to guess. We will create a variable of guess and accept some user input. We'll prompt the user to enter a letter. Just in case a user types in a character that's uppercase, let's add the lower method to make it lowercase. So let's fill in our displayMan function. There's not a lot to write here. When we call this function, we need to display one of these images based on the wrong number of guesses, one of these keys. Within the displayMan function, we'll create a for loop. For every line in my hangman art, this dictionary, at the key of wrong guesses. This will be a number, 0 through 6. Depending on what this number is, I will print each line. Print each line of that tuple. Let's see what we're working with. We'll do a test run. So we are displaying no person. We can't see them. For testing purposes, I'm going to change wrong guesses to be 1. We're displaying their head. 2 displays their body. 3 displays their left arm. 4 is their right arm. 5 their left leg. And 6 is their full body. That's when we lose. Now, you don't necessarily need to do this, but I'll add some text decoration before and after. I'll add just a bunch of asterisks before and after. I think that looks better, but you do you. Let's be sure to set wrong guesses back to 0. After we display our hangman, we have to display the hint. What's the clue we're trying to solve? So we will call our display hint function and pass in our list of hint. So within the display hint function, let me zoom out, I will print the following. Between each character within our hint, each underscore, we will display a space character. Strings have a built-in join method. We'll call that, then pass in our hint. For each character within our hint, join it by an empty space. So now when we do a test run, we are displaying an underscore to represent each character. Each is separated with a space. While we're here, we'll fill in the display answer function. We just have to copy this line of code from display hint, replace hint with answer. And that's all we need for the display answer function. So let me test that real quick. After displaying our hint, temporarily, I will display our answer, just to be sure that it's working. Yep, there's our hint, and there's our answer that we have to guess. Okay, let's delete this line of code. We don't want to display the answer. I was just testing it. So the user is going to be able to type in a letter to guess, such as A, for example. Once we guess a letter, if that letter is found within the hint, if it's one of these characters, we need to switch that underscore to be one of those characters. So we'll write the following if statement. If our guess is in our answer. In is a membership operator. If this letter is found within our string of answer, we're going to create a loop. We will create a loop that will iterate once for each character within the answer. But we don't know the length of the answer because Python will choose it at random. So let's say for every index, we can shorten this to I. For I in range, the length of my answer. Let's say the word is apple. The length of the word apple has 5 characters. This would return 5. For I in range 5. Then we will iterate 5 times. We'll iterate this loop once for the number of characters within my answer. We'll check during each iteration if our answer at index of I, during the first iteration, that will be 0. Then the second iteration, it will be 1, then 2, so on and so forth. Strings are iterable. If our answer at index of I is equal to our guess, if there's a match, if we guess the correct letter, then we're going to take our hint at that given index of I and set that equal to be our guess. Looks like this if statement is outside of the while loop. I'm just going to indent it by 1, so we're within it. Okay, let's do a test run. I'm going to guess the letter A. Yes, we have one A. Let's do something that's probably not in here. Q. Okay, so there were no matches. We don't end up doing anything. So what is this word probably? This should be the word orange. So let's guess O, R, N, E, G. All right, we know that it works. What if somebody types in some input that's not valid? Before checking if that guess is correct, we'll do some input validation. What if the user types in a whole word, like pizza? We want the user to only guess a single character, not many characters. We'll add the following line. If the length of our guess that we type in does not equal 1, then I will print the following message. Let's say invalid input. Then we will use the keyword of continue to skip this loop. Continue. Okay, enter a letter. I will type the word pizza. We get this message of invalid input. We skip that loop's current iteration. I will guess A. There are 2 A's. I will type banana. And again, we get invalid input. We have to guess 1 letter at a time. What if somebody types in a number, like 1? We would like to prevent that. So within this if statement, I would like to execute this code if our guess is not an alphabetical character, I can add the following. Or not take our guess, dot, use the is alpha method. If our guess is an alphabetical character, this returns true. If it's not an alphabetical character, it's false. So we are checking if this is not an alphabetical character, we execute this code. Let's try this again. I will type in 1, invalid input, 42069. Invalid input. Let's say we guessed the letter A. What if we type in a letter we have already guessed? I will guess A again. If they already guessed a letter, I don't want that to count. We'll skip the current loop iteration. I'll add another if statement. If our guess is in our set of guessed letters, then I will print the following. I'll use an F string. Our guess is already guessed. Oh, one thing I'm forgetting. Once we check that our guess is not within our guess characters, we'll take our guess letters, this is a set, add the guess. We're keeping track of the letters we have already guessed. So I will type, let's guess A. We have one A. If I were to guess A again, we get that message of A is already guessed. And then be sure to add continue to skip the current loop iteration. All right, now going down to this if statement, if guess is in our answer. If we guess a character that's incorrect, we will take our variable of wrong guesses, increment it by 1. Wrong guesses plus equals 1. Let's do a test run. I will guess A. There is an A. What about Q? There is no Q. We display our dictionary where the key is 1. We display that ASCII art. R? Is there an R? Yes, there is an R. This is probably orange. I would like to be sure we display the entire person. I will guess some wrong characters. We know that that works. Now we need a win condition if we guess all of the correct characters and display the entire word. We'll work on that next. If there are no underscore characters, not in our hint. This will be true if there are no underscore characters in our hint. If underscores not in hint. We'll call our function of displayMan, pass in the wrong number of guesses. Call the function of display answer. Pass in our answer. We will print the text of you win, then set our Boolean variable of is running equal to be false. Let's win this time. I already know that this word is probably pineapple. Let's guess something incorrect. There we go. We have 2 wrong guesses, but we have correctly guessed the word pineapple. You win. And we exit the program. What if we lose? I'll add the following if statement. Else if our variable of wrong guesses is greater than or equal. So the length of our hangman art is a total of 7. There's 7 total keys. But once we hit 6, we lose the game. With this else if statement, if the length of our hangman art, the length of our hangman art is going to be 7. So we are going to subtract 1 for 6, for a total of 6. Once our wrong guesses is greater than or equal to 6, that means we lose the game. We will call the displayMan function, pass in the wrong number of guesses. display what the correct answer should have been. Display answer, pass in our answer. We will print you lose, then take our Boolean variable of is running, set that to be false. I'll guess incorrect letters. There, the word was coconut. We have 6 incorrect guesses. We display the entire hangman. The correct answer was coconut. You lose. If you would like to import a larger variety of words, we could create a separate Python file for that. So within our project folder, we will create a new Python file. I will name this Python file words list. This will be a Python file. Let's take our set of words, cut it. I'll add a note that these are words for hangman game. Words will be a set. I recommend looking online for a very large set of words that we can use. Then just copy and paste them within here. While browsing online, I found an extensive list of animals that I can use. So here are all the possible words for my game. So, from my main Python file, I have to import this module of words list. From the module of words list, import words. And now I have a greater variety of words I can use. Let's run this one last time. This word has 4 letters. I'll guess the vowels. There's an A, no E, I, O. There is an O. Is it goat? Nope. T. R. Boar. All right, the word was boar. You win. All right, everybody, so that is a game of hangman that we can create using Python. All right, everybody, so in today's video, we're going to create a working alarm clock using Python. For this project, we will need the following imports. We will import time. We'll be updating our clock every second. The time module is going to help us with that. As well as import date time. The date time module allows us to work with string representations of a time. In my opinion, the easiest way to work with sound effects is to actually use Pygame. So we will import Pygame. Now you may need to download the Pygame package. Here I'm getting a message that there's no module named Pygame. There might be a link to install it even too. One way in which you can download the Pygame package is to open up a terminal, then use pip. Pip is Python's package manager. Pip install Pygame. Alright, we have our 3 imports. Let's create a function to set alarm. We have 1 parameter, an alarm time. And for now, I'll write pass. Our alarm time parameter is going to be a string representation of a time in military time. I would like to start this program if I'm running my main Python file directly. I can add the following if statement. If dunder name is equal to a string of dunder main. If we are running this main Python file directly, then we will set the alarm. But first, we have to prompt the user what they would like to set the alarm to. So we will define a variable of alarm time equals ask for some user input using the input function. We will prompt the user to enter the alarm time and give a format. Hours, minutes, and seconds. Again, this is going to be in military time. Once we have our alarm time, we will call the setAlarm function and pass in our alarm time. Alright, we are now within the setAlarm function. When we call this function, let's print the following. I'll use an f-string. Alarm set for, then include the alarm time. you will need an MP3 file to work with. If you don't have one available, here's one recommendation. You could use YouTube's audio library, and then search for sound effects or some music. These audio files are only allowed for non-commercial use outside of YouTube. So you can search for a song or some sound effects, find one that you like, and download it. Once you find a song that you like, move it to your project folder. Now, I will create a variable of sound file equals. This will be a relative or absolute file path. My MP3 file is right next to my main Python file. I only need to list the file name. I named mine My Music, and this is an MP3 file. I'm going to perform a test run. We're not going to play our sound quite yet. We do have this output that displays that says hello from the Pygame community. Let's say I set my alarm to 9 a.m. Then enter, alarm set for 9 a.m. If you would like to suppress this output for Pygame, we can navigate to our virtual environment, go to Library, Pygame, underneath this file named dunder-init. Let's scroll all the way to the bottom, and we should have this if statement. We display the version of Pygame we're using, and a print statement of hello from the Pygame community. We could comment this out, or even just delete it. That is the most simple solution. So we shouldn't get that message anymore. We're going to create a Boolean variable of isRunning. Is our alarm clock running? I will set that to be true. While isRunning, while this is true, we will continue the alarm clock. We need to get the current time. Current time equals, we will access the datetime module, access the class of datetime. Call the now method to get the time and date right now. We could method chain the string format method, strf time. I would like the hours, minutes, and seconds, but not the date. So we will type %h, colon, let me zoom out a little, %m for minutes, and %s for seconds. We're getting the hours, minutes, and seconds of the date and time right now, and storing it within this variable of current time. Then I'm going to print the current time. We'll perform a test run. However, currently we're within an infinite loop. At the end of the while loop, I'll set isRunning to be false. Okay, enter the alarm time. Let's say 10 a.m. Alarm set for 10 a.m. And the time for me right now is 9:42 and 16 seconds. We'll get rid of this line where we set isRunning to be false. Instead, I'm going to access the time module and call the sleep method. We will pass in a number of seconds to sleep, so 1 second. I'll set the alarm to be 10 a.m. Now the time should update every second, which it is. However, when the current time is equal to the alarm time, we have to trigger the alarm. So after printing the current time, we will write an if statement to check if the current time is equal to the alarm time. If this is true, then let's print the following. Wake up. And I'll add an emoji, because it's silly. Once our alarm triggers, we will set isRunning to be false within this if statement. Let's do a test run. We're not going to play the sound quite yet. I will set the alarm to 9:45. And then I'll come back a little bit later. Alright. Once the current time matches the alarm time, we print wake up and set isRunning to be false to exit the while loop, and then subsequently exiting the program. Now we need to play an MP3 file. We will access our package of Pygame, access the module of mixer. So mixer is a module for loading and playing sounds, but we have to initialize it. But we're going to initialize it with init to initialize. The initialize method is another way to call the constructor. We can pass in some keyword arguments for the frequency, size, channels, buffer, all that, but that might be a little too complicated for us at this level. We'll use the default settings by not passing in anything. The next step is to load our sound file, access the package of Pygame, access the module of mixer, access the module of music, then call the load method. We will load our sound file. Our sound file contains the file path to our MP3 file. Once we load our music, we have to play it. Pygame.mixer.music, call the play method. Our MP3 file is only going to play for a brief second. I'll demonstrate that. I will set the alarm to 9:49 and just give it a few seconds. Our sound file stops playing when the program terminates. What we need to do next is continue playing our sound file while that sound file is busy. We will add a while loop. While access pygame.mixer.music, call the getBusy method. This returns a boolean. If our song is busy, if it's still playing, then we will call the time module's sleep method and sleep for 1 second. Once the song finishes, or we terminate the program prematurely, the sound file will no longer be busy. So this should be the finished product. Let's test it. I will set the alarm for 9:52, and we just have to give it some time. Alright everybody, in today's video we're going to build a digital clock widget using Python's PyQt5 library. If you're new to this channel, I have previously released a course on PyQt5. In that series, we've downloaded the PyQt5 package. It's found within the library folder of our virtual environment within our project folder. If you don't have this package, you will need to download it. You can open up a terminal, then type the following command: pip install PyQt5, enter. So I already have it installed. Be sure that this package of PyQt5 is within your site packages folder. So let's begin. At the top of our Python file, we will need the following imports. Import sys. Sys means system. This module provides variables used and maintained by the Python interpreter. We would also need widgets. Widgets are the building blocks of a GUI application. From the package of PyQt5, we need to access the module of Qt widgets. Import the following: Q application, Q widget. This is a generic widget. We'll turn our digital clock into its own widget. And Q label to work with labels. We will be using a layout manager, more specifically QV box layout. There's another import we'll need too. From the package of PyQt5, access the module of Qt core. The Qt core module, it provides functionality not related to GUI components. This is where we'll get a timer to keep track of the time. From this module, we will import QTimer, QTime, and Qt. Qt is for alignment. We will create a class of digital clock. Instead of inheriting from the main window widget, we will inherit from the base class of QWidget. QWidget is a base class to create our own widgets. Our digital clock will be a widget. We will need a constructor, so let's define that. Define init, pass in self. If there are any arguments to send to the parent, we will call the constructor of the parent, the superclass. Super, call the init method. At the end of the constructor, what I like to do is call a method of initialize UI. Init UI. This will be a separate method. Define init UI. There are no parameters besides self. And for now, I'll write pass. It's within this method that we will be designing the layout of the digital clock. Within the constructor, that's where we will be constructing all of the different entities for the clock. At the end of my Python file, I will add the following statement. If dunder name is equal to a string of dunder main. This statement will be true if we are running this program directly. To create an application, we will create an app object equals, call the constructor within the class QApplication. As an argument to the constructor, we will pass in the following argument. Access the module of sys argv, which means arguments. This would apply if we're running from command prompt or terminal, but we won't be doing that in this video. But it's nice just to set it up in case we do in the future. Now, we are going to create a clock object. Clock equals, we will call the constructor of our digital clock class. There are no arguments. Now, the window doesn't appear. That's because we have to use the show method of our clock. Take our clock, call the show method. Now, it's only going to appear for a brief second. Just momentarily, I don't know if you saw that. To ensure a clean and proper exit of our application, we need to call the following method. Access our module of sys, call the exit method, then pass in the following. We will take our app object, then call the following method. exec underscore, and then a set of parentheses. It's a method. It's the execute method. It starts the main event loop of the application. It also handles events, such as key presses, mouse clicks, or other user interactions. So then, we should have a window that stays in place until we exit. Okay, now we have the base functionality all set up. We have a class of digital clock that inherits from the QWidget base class. We're not going to be using main window in this video. Within the constructor of my digital clock, I will create a label, self.time label. This will be a label that displays the time. We will call the constructor within the class QLabel. Then be sure to pass in self. We will be adding this label directly to our widget of clock. We will need a timer, self.timer equals, call the constructor of QTimer, then pass in self. We are adding the timer to the clock. Now with designing the layout of our clock, I'll handle that within the initialize user interface method. We're going to set a title for the window. Self.set window title method, pass in a string that will be used for the title of the window. Let's say digital clock. Then our window should say digital clock. Let's set the geometry of the window. Self.setGeometry. The first two arguments are going to be for the placement of the window. Where will it appear within your screen? So I'll pick something approximately in the middle for me, but feel free to change these values. Then we need a width for the window, let's say 300, and a height, 100 for the height. So my window should appear approximately in the middle of my screen. The base width is 300, the base height is 100. Now we're going to need a layout manager. I will name this layout manager VBox for a vertical box. VBox equals, call the constructor within the class QVBox. This will arrange all of our widgets vertically, but we only have one widget, a time label. So we will take our layout manager of VBox, add widget, that's a method. We will pass in self.timeLabel as an argument. We're adding our label to this layout manager of VBox. Then to set the layout, we will take self, that applies to our clock, call the set layout method, then pass in our layout manager, a VBox. So currently if I run this, we don't see anything. Temporarily within our label, I will add some text just as a placeholder so we can see what we're working with. Let's say 12 o'clock. So then we should see something at least, although the font is kind of small. We will be getting rid of this later. We just want to be sure that we can see everything. Alright, so after our layout, I would like the label to be center aligned horizontally. Here's how we can set that up. We will take our label, self.time label, call the set alignment method, access the class of Qt, access align center. This should center align our time. Now let's work on the font. I can barely read it. We will take our label, self.time label, set style sheet. We can pass in multiple CSS-like properties. Let's set the font size. I'll set it to be 150 pixels. Now we can read it. You could pick a font, but we're going to change that at the end of this video. We'll import a custom font. But temporarily, let's say font family Arial. You could change the color too. So if I set the color to be green, then the font color is going to be green. But I would like a very specific shade of green. You could always Google a color picker, then pick a very specific color. Let's go with that, something that's bright green. You can copy the hex value, RGB, or HSL. HSL means hue, saturation, and lightness. I'll use HSL values. For the color, we will type HSL, add a set of parentheses, then paste those values. But there is a degree symbol, you do have to get rid of that. Now the font color is going to be bright green. Let's change the background color. Here's how. We will take self, that applies to our clock, then call the set style sheet method, pass in a background color. We will set the background color property to be black. I think that looks pretty good, but it doesn't quite do anything quite yet. That's the next step. Let's create a method to update time. No arguments besides self. I will create a local variable of current time equals. Now to get the current time, we can access the class of QTime. QTime dot call the method of current time. We will need to convert it to a string. We will method chain the toString method. Within the toString method, we will design the layout of the time. So I would like hours first. I will type 2 H's, colon, minutes, that's 2 M's, colon, 2 S's. To set the text of the label, we will take self.timeLabel, call the setText method, then pass in our current time. So if I run this currently, we still have our placeholder time. Let's update it with the current time. We can get rid of our placeholder text of 12. We can delete it. After we set the font, let's call the method of update time. Self.updateTime. Now we should display the current time. So I'm recording this video at 7:44 in the morning. If you would like to add AM or PM after your time, here's how. After our string format specifiers, we will add capital AP. A means ante-meridium, and P means post-meridium. So then we should display AM or PM, depending on when you're coding this. Currently the time for me is 7:45 AM. To get the clock to update every second, we need to connect our timer widget to a slot of update time. We will take our timer, self.timer. This isn't the time label, it's the timer to keep track of the time. During a signal of time out, we will connect the following slot of self.updateTime. Self.updateTime. With our timer, we need to trigger a timeout signal every 1,000 milliseconds. Every second, that is. To handle that, we will take our timer, self.timer, call the start method, then pass in 1,000 for 1,000 milliseconds. So then, when we run this program, our clock should update every second and display the new current time. As an added bonus, if you would like to download a custom font, here's how. Using Google or another search engine, I would recommend looking up a font of your choosing. So one font that I like is DS Digital. What we need is a TTF file, meaning true type font. I'll just pick this first link. So these fonts are pretty good. So I'm going to download them. I'll pick this specific font, DS Digit, and again the file extension is TTF. So once you have your font, move it to your project folder. So for convenience, we have that TTF file right next to our main Python file. Okay, to work with specific fonts, we will need the following import from pyqt5.qt.gui import q font as well as q font data base. Since we're going to use our own custom font, we can delete that from the setStyleSheet method of our time label. So let's set the font right here. We will assign a local variable of font ID equals q font data base. QFont database is a class for managing and querying fonts available to the application. To add a custom font, we will call the following method within it: add application font. Within the set of quotes, we're going to pass in a file path. This can be a relative file path or an absolute file path. This TTF file is right next to my main Python file. I only need the file name. My font file is named ds-digit and get the file extension of TTF. We will create a local variable of font family. We will retrieve the name of the font family from this ID. Again, we will access qfontdatabase dot call the application font families method. So this method returns a list of font names. We will pass in our font ID, but there's another step. We're going to use the index of operator and get the index of 0. This will retrieve the first element of the font family. That's because we're working with a list. We will need just the first element at index 0. Now we'll have a font family to work with. Now to set the font, we will create a local variable of myFont equals call the class, call the constructor within the class qfont. Pass in the following arguments: our font family, that's the first argument, and then a font size, let's say 150. To set the font, we will take our time label, self.timeLabel, call the setFont method, then pass in myFont, our custom font. So then we should have our custom font, that digital font that we've downloaded. Alright everybody, so that is how to create a digital clock widget using pyqt5. Hey everybody, so in today's video we're going to create this stopwatch program using Python's pyqt5 library. If you've been following the pyqt5 series up until this point, you can skip ahead to the following timestamp, where we've already set up a basic application. You just have to make some minor changes. If you're new to this series or new to this channel, you will need the pyqt5 package found within your site packages folder. If you don't have this package, you can open up a terminal to download it. You can use pip, which is Python's package manager, install pyqt5. But I already do have it installed. Once that's out of the way, you will need the following imports. Import sys. Sys means system. It handles system variables for your Python interpreter. We will need the following widgets. From PyQt5, access the module of Qt widgets. Widgets are the building blocks of a PyQt5 application. We will import the following widgets. Q application, Q widget, Q label, Q push button, QV box layout, and QH box layout. Let me put these on a new line just so we can read everything. From the package of PyQt5, access Qt core. We will import Q timer. Our timer will emit a signal after a given interval, which is what we need for a stopwatch. Q time to keep track of the time, and Qt for alignment. Let's do a test run to be sure that there's no errors. Looks like L in label should be capital. There we go. No errors. Once you have the following imports, we will construct a class of stopwatch, which will inherit from the base class of QWidget. Our stopwatch will be a widget. We will need a constructor. We'll define that. Dunder init. No arguments besides self. If we have arguments to pass to the parent of QWidget, we will call the superclass the parent. Call the constructor of the parent. No arguments currently. Now, if we are running this file directly, we'll use an if statement to verify that. If dunder name is equal to a string of dunder main, if this is true, if we are running this file directly, then we will construct a stopwatch. We will create an app object, call the constructor within the Q application class, pass in the following: access sys, our system, access argv, which means arguments. This is if we're using command line arguments, which we won't be using, but it's nice to future-proof our code just in case we do in the future. We will create a stopwatch object. Stopwatch equals, call the constructor within our class of stopwatch. Our window is not going to show unless we call the show method. Take our stopwatch, call the show method. Now our window is only going to show for a brief second. We need to ensure a clean exit. We can access sys, call the exit method, pass in the following: app, then call the exec underscore method. This method starts the main event loop and handles events. So then we should have a basic window, which stays in place until we close it. We now have the main skeletal structure of a PyQt5 application set up. If you're one of the people that have jumped ahead up until this point, we have a class of stopwatch, which inherits from the QWidget class. We've constructed a stopwatch object, and we're showing it. So now we can begin designing our stopwatch. We will create a time object, self.time equals, call the constructor within the class of QTime. For arguments, we'll pass in the hours, minutes, seconds, and milliseconds, all 0. We need a label for the stopwatch. Self.time label equals, call the constructor of QLabel. What would we like the text to say? I'll display some placeholder text. A bunch of zeros. 0 hours, minutes, seconds, and milliseconds. We will add this label to self, our stopwatch. We need a start button, self.start button equals, call the constructor within QPushButton. What would we like the text of the button to say? Let's say start. We are adding this button to self, our stopwatch. We need a stop button. Let's replace start with stop. Change the text from start to stop. And reset. The name of this button will be the reset button. The text will be reset. We will need a timer to emit a signal at a given interval. Self.timer equals, call the constructor within the class QTimer, then pass in self. We're going to call a method of initializeUI, self.initUI. But we still have to define this method. Alright, within our stopwatch class, we need the following methods. A method of initUI. This is where we'll be designing the user interface. I'll write pass for now as a placeholder. We need a method to start the stopwatch, that is. A method to stop the stopwatch. A method to reset the stopwatch. We'll create a method to format our time. Format time. Besides self, there's one parameter. We have to pass in a time to format. We will be returning a string representation of the current time. And a method to update our display. Update display. Here are the 6 methods we'll need. Within our initialize user interface method, we will set the title of the window, because right now it says Python. We will take self, our stopwatch, call the set window title method, and we will pass in stopwatch. That should change the title of the window to stopwatch. We're going to use a vertical layout manager for the label and the buttons. We will create a layout manager named vbox. Vbox equals, call the constructor of q vbox layout. We will take our layout manager and add the following widgets. Self.timeLabel, then our start, stop, and reset buttons. Start button, stop button, and reset button. We will take self, set the layout, pass in our vertical layout manager. So we have all of our buttons. We have our widgets arranged in a column. We're going to take our time label and also center it horizontally. We will take our time label, self.timeLabel, call the set alignment method, access our class of Qt, access the flag of align center. That's going to center align the time. It should be aligned both vertically and horizontally. Now with your buttons, they're arranged in a column. We could group them together horizontally. Here's how. We will create a horizontal layout manager of hbox. hbox equals, call the constructor of qhbox layout. Instead of adding these buttons directly to our vertical layout manager, let's cut them, paste them underneath hbox, replace vbox with hbox. Then with our vertical layout manager, vbox, we will add our layout of hbox. This group of buttons is arranged vertically with the time label. Now we'll be applying a style sheet. Access self, our stopwatch, call the set style sheet method. We can pass in one extremely long string with a set of triple quotes. All of the CSS-like properties we'll add will do so between the set of triple quotes. Let's select our buttons. Q push button. We are selecting an entire class. Within a set of curly braces, let's add the property of font size. The font size of all buttons will be 50 pixels. Let's customize our label. Select the class of QLabel. Within a set of curly braces, let's add the following properties. Font size will be 120. If you would like, we can add a background color too to the label. we can select a background color. Temporarily, I will select blue, but we can pick more specific shades of blue or another color. Here's how. You can look up a color picker and select a very specific color. You can use hex values, RGB, or HSL. I've already selected a color. I'm going to copy these HSL values. So instead of a color name, we will select HSL, then paste those values. If you have a degree symbol, you will need to remove that. And now we have a very specific shade of blue. I will also round the corners of our label. Add the property of border radius. I will set that to be 20 pixels. This will round the corners. Between each button and label, we'll add some padding. We're going to use multiple selectors. We will select all push buttons and all labels. Apply the following properties to each. I will add padding of 20 pixels around these widgets. And I will also make the font weight bold. Font weight will be bold. Alright, I think that looks pretty good. Hey, this is Bro from the future. I am currently editing this video. If you would like, you can add a font family. One font that I think looks really good is Calibri. We'll apply that to all push buttons and Q labels. I really like this font. I think it fits a stopwatch, but it's up to you if you would like to change the font. I just thought I would mention that. Now we just have to add some functionality, because these buttons don't do anything. For each of our buttons, we have to connect a signal to a slot. We will take our start button, self.start button. With the signal of clicked, we will connect the following slot. We will call the start method, self.start method. Let's do this with the stop button. Change start to stop. Clicked, connect, self.stop method. Reset. Self.reset button. Call the reset method. At a given interval, we're going to update our display. Self.timer. During a signal of timeout, we will connect the following method, self.updateDisplay. Self.updateDisplay. Within our start method, we will take our timer, self.timer, call the start method, pass in 10 for 10 milliseconds. We will set an interval for a timeout every 10 milliseconds. Within our stop method, we will take our timer and instead call the stop method. We'll get back to reset in just a moment. Let's work on the format time method. From our time that we pass in, we have to get the hours, minutes, seconds, and milliseconds. We will create some local variables. Hours equals access our time that we pass in, call the hour method to return hours. We have variable minutes, time dot call the minute method to return the minutes. We have a variable of seconds, seconds equals take our time, call the second method. Then for milliseconds, access our time, call the MSEC, which means milliseconds, and call it this is a method. I'm going to return a string, an F string, to represent the time. We will add 4 placeholders. Hours, minutes, seconds, and milliseconds. Each will be separated with a colon, except for milliseconds, which will be a dot, a period. We will display the hours. I'll add some leading zeros, 2 leading zeros. Let's do this for minutes. We're using a format specifier for 2 leading zeros as well. Seconds. And milliseconds. Now we will work on the update display method. We have to get the time. Self.time equals we will take our time, but call the add milliseconds method, MSECS, then pass in 10 for 10 milliseconds. We're going to take our time label, self.time label, and set the text of it. We will call our format time method, but we have to pass in a time. We will be passing in self.time. Let's see what we have currently. We can start the stopwatch, and we can stop it. However, we're displaying 3 digits for the milliseconds. We can eliminate that. Within format time, when we get the milliseconds, we will use integer division. We will divide by 10. This will convert our milliseconds from 3 digits to 2. We're basically dividing by 10. So here's our stopwatch currently. We can start, we can stop, we can start again, and we can stop again. Now we just need to reset. Here's how. Within the reset method, we will take our timer, self.timer, use the stop method to stop. We will reassign our time, call the constructor of QTime. We have to pass in hours, minutes, seconds, and milliseconds. They're all going to be 0. We're resetting our time. And then we'll reset the text again of our time label, self.time label, call the set text method. When we set the text, we will first format it with the format time method, but we have to pass in a time. We will pass in self.time. And now we should be able to reset our stopwatch. We can start, we can stop, we can reset, start again, and stop again. All right, everybody, so that is a cool stopwatch that you can make using Python. Hey, what's going on, everybody? So in today's video, we're going to create a working weather app that fetches real-time weather data from an API. This is a massive project, so feel free to take your time. Take several days or even weeks if you need to complete this. Heck, you can even add this project to your portfolio. Well, let's get started, everybody. Alright, let's get started, everybody. This is a fairly useful API to get real-time weather data. The website is openweathermap.org. You will need your own API key, but signing up for an account is free. To create an account, we'll go to Sign In, create an account, enter your information, and then sign in. Once you're signed in, to find your API key, go to this drop-down menu, go to My API Keys, and you would just need to copy this API key. If the status is inactive, you'll need to toggle it to active, like so. Now, it may take several minutes for your API key to become active. Hopefully by the time of this project where we will need it, it'll be active. I would either leave up this window or copy this key and paste it somewhere. If you're new to my Python series, we have a little bit of setup to do. You will need the PyQt5 package installed. If you've been following my series, you can skip ahead to the following timestamp. At this point, we'll already have a basic window set up. To download PyQt5, you can open up a terminal and use pip, which is Python's package manager, to install PyQt5. And myself, I do already have this downloaded. Once you have this package downloaded, and it's within your site packages folder, we will need the following imports. We will import sys. Sys means system. It handles system variables for your Python interpreter. We will import the requests module to make a request to an API. Then we'll need widgets. Widgets are the building blocks of a PyQt5 application. From the package of PyQt5, access the module of Qt widgets. Import the following widgets: Q application, Q widget, Q label, Q line edit, Q push button. Let me put some of these on a new line for readability. Q v box layout. This is a vertical layout manager. To work with alignment, we'll need the following: from the package of PyQt5, from the module of Qt core, import the following class, Qt, which is used for alignment. So these are the imports that you'll need. Just to be sure that I didn't misspell anything, or get the capitalization wrong, I'm just going to do a test run. No problems. Processed finished with execode 0. Sometimes I make one of these characters lowercase, and then it doesn't work. Okay, we have our imports. We will need to create a class of weather app. Weather app is going to inherit from the parent of QWidget. We will need a constructor, so we'll define that. Dunder init, no arguments besides self. In case we have arguments to send to the parent, we will call the parent with super, meaning the super class, then call the constructor. But currently, we don't have any arguments. If we are running our main Python file directly, we can verify that with an if statement. If dunder name is equal to a string of dunder main. If we are running this file directly, then we will create a weather app object. Otherwise, we won't. If this statement is true, we will do the following. We will create an app object. App equals, call the constructor within our QApplication class. But we will pass in the following. Access the module of sys, then access argv, which means arguments. If we have command line arguments to send to our application, this is how we would take care of that. But we're not going to be using command line arguments in this video. But it's nice to future-proof our code, just in case we do. We will construct a weather app object. Weather app equals, call the constructor of our weather app class. Now this window isn't going to show. We have to call the show method of our weather app. weatherapp.show. And now it's going to show for a brief second. We need to ensure a clean exit. Access sys, call the exit method. Within this method, we will pass in the following. Take our app, call the execute method, which is exec underscore. It is a method, so we have to call it. This method handles events within our application, such as closing the window. So now our window should stay in place until we close it. If you're one of the people that have jumped ahead, we have created a class of weather app, which inherits from the parent of QWidget. We've constructed a weather app object, and we're showing it. If you've made some PyQt5 projects in the past, you would just have to change some of these around. Within the constructor of our class weather app, we will declare the different widgets that belong to our weather app object. We will create a label that prompts the user to enter in a city. We will name this city label. Equals, this is a Q label widget. We can set the initial text of the label. Let's say enter city name. Then the second argument is going to be self. We are adding this label to our weather app object. Here's what we have currently. We still have to do some CSS formatting, but we'll take care of that soon. We will need a line edit widget, basically a text box. We will name it city input. The widget is line edit. No parameters besides self. Here's our line edit widget. We're not currently using a layout manager. These widgets are going to overlap. We need a button, self.get weather button. This is a Q push button. The text on this button will be get weather. We are adding this to self, our weather app object. Here's our button. When we click on this button, we'll make a request to an API. For the next following widgets, we're going to add some placeholders, just so that we can see what we're doing when we apply CSS styling. We need a temperature label to display the temperature. Temperature label equals a Q label. Temporarily for the label, let's say that the temperature is 70 degrees Fahrenheit, or pick something else in Celsius. So to add a degree symbol, if you're using Windows, make sure numlock is on, hold Alt, then on the numpad type 0176. I will pick 70 degrees Fahrenheit. And then we will add this to self. Again, we're just using this temperature as a placeholder. We'll delete it when we do a test run. If you would like to include an emoji or some other image, we can create a label for that. I will name this emoji label equals a Q label. I will add an emoji of a sun as a placeholder. Again, we're going to delete this when we do a test run. We are adding this to self. Again, everything is overlapping. That is fine. And we need a description of the weather. Description label equals a Q label. As a placeholder, let's say that it's sunny. And we are adding this label to self. Okay, here are all the widgets. They're all overlapping. So we need to fix that. Alright, moving on everybody. So now we have to design the layout of our web app. Right now, all of our widgets are gravitating to the top left corner. So I will define a method to initialize our user interface. At the end of this constructor, we will call this method self.initializeUI, then call it. Once we've constructed our widgets, we'll format them and design the layout. So we are now within our initialize user interface method. First, let's set the title of our window. Self.setWindowTitle. Let's say that the title is Weather App. So that should change, which it does. We're going to use a vertical layout manager to handle all the widgets. Let's name the layout manager VBox equals, call the constructor of the class QVBoxLayout. We're going to take our layout manager of VBox, then add a widget. We will start with the city label. That's first. We will pass in self.cityLabel, and we'll do this with the other widgets too. We have city input, get weather button, temperature label, emoji label, and then a description label. Take self, our weather app, set the layout. We will pass in the layout manager of VBox. And here's what we have currently. All the widgets are arranged in a column. Now we just have to center align them horizontally. Here's how. We will take self.cityLabel, call the setAlignment method, access the class of Qt, access the flag of Align Center. We're going to align all of our widgets in the center, except for our weather button. Currently, our button expands to take up the width of the window, so we don't need to horizontally align that. So we have 5 widgets to align. We have city label, city input, temperature label, emoji label, and description label. All of the widgets are going to be arranged in a column horizontally. Now we just have to apply some CSS styling, because right now it's kind of ugly. We will apply styles based on an object name, but we have to set that object name. So let's start with our city label, self.cityLabel, call the setObjectName method, pass in a unique ID for this widget. I will name it CityLabel. I'll keep it the same. Okay, we have to do this with the other widgets too. We have a total of 6. We have city label, city input. We have the get weather button, temperature label, emoji label, and description label. Then we're going to set a style sheet. Take self, our weather app, apply a style sheet with set style sheet. We have a lot of properties to write. I will do so within a set of triple quotes, just to keep everything more organized. We can apply CSS styles based on a class. So the class is going to be QLabel. Within a set of curly braces, we can list multiple CSS properties. I will set the font family to be Calibri, as well as all push buttons. Q push button. So here's the font, although it's still kind of small. Let's select our ID of city label. It's good practice to precede this ID with the name of the class. So QLabel, #, the ID. We precede the ID with the name of the class, just so we're only applying these CSS properties to any ID that's a city label that falls within the class of QLabel. Let's set the font size to be 40 pixels. Let's set the font size to be 40 pixels. That's better. I'll set the font style to be italic. Font style, italic. That's pretty good. Let's select the ID of city input. This is a line edit widget. Q line edit #, the ID of city input. Within a set of curly braces, let's set the font size to be 40 pixels. We will select our push button, which is named getWeatherButton. The class is Q push button #, the ID of getWeatherButton. Within a set of curly braces, we will apply the following. Let's set the font size to be 30 pixels. And let's make it bold. Font weight bold. Let's select our temperature label. The ID is temperature label, and this is a Q label #, temperature label. We will increase the font size. Font size 75 pixels. Better. Let's work on our emoji next. We will select the ID of emoji label. The class is QLabel. The ID is emoji label. We'll set the font size first. Font size 100 pixels. I would like a large image. To display emojis properly, we're going to use a very specific font. We're going to set the font family to be, now I don't know if I'm saying this right, SEGOUI emoji. I probably pronounced this word wrong, but I don't care. So then our emoji should display correctly using this font. It's colorful. Then we have the description label of the weather. That is the last widget, description label. The class is QLabel. The ID is description label. Let's take the font size and set it to be 50 pixels. Alright, so this is what our weather app is going to look like. We have the city label, a text box to enter in a city, the get weather button, the temperature label, an emoji label, and a description of the weather currently. Now we just have to add some functionality because currently this doesn't do anything. Alright, so now we just have to add some functionality to our weather app. Temporarily, I'm going to collapse our initialize user interface method. We will define a few extra methods. Let's declare a method of getWeather. No parameters besides self. I'll write pass for now as a placeholder. We will need a method to display any errors. Display error. There's going to be one argument besides self, a message. We will pass in an error message, if there is one. And a method to display weather. That's if there's no errors. We will need some data, our weather data. So be sure that you write these three methods. Back within our initialize user interface method, at the bottom, we have to connect a signal to a slot. When we click on the button with the signal of clicked, we will connect a slot of getWeather. We will access self, take our getWeather button. With a signal of clicked, we will connect a slot of self.getWeather. And I will print a test message, just to be sure that it's working. You get the weather. So I press the button, and we will display, you get the weather. We can get rid of our placeholder text for the temperature, our emoji, and the weather description. So we can delete these strings. But be sure to keep self. Scrolling down to our getWeather method, when we click the button, we're going to create a few local variables. The first is going to be our API key equals, this will be a string. Back to the OpenWeather API, you will copy your API key and make sure that it's active. You can use the toggle button to make it inactive and active. So make sure that it's active. Paste your API key within a string. Please use your own. It still may take several minutes for your key to be active. Just keep that in mind. We will need to get the city that we're looking up. So let's say we type in Miami. I have to get the text from this widget, this line edit widget. We will create a local variable of city. City equals access our line edit widget. It had a name of city input. So self.cityInput, to get the text, we will call the text method. We have the API key and the city. Now we will create a URL. This will be an f-string. Using the request module, we will pass in a URL to make a request to. So back to our OpenWeather API. To get the URL for a city, we have to go to the tab of API, scroll down to current weather data, and there's going to be some API documentation. To the right, we have a link for built-in API request by city name. We will copy this URL and paste it within our f-string. There's two changes we're going to make. We will replace city name with city, the name of that variable, and API space key with API underscore key. It doesn't matter what you name these, just make sure they're consistent with your variables. When we make an API request, we will be returned with a response object. Response equals access our module of requests, call the get method, then pass in our URL. With our response object, we have to convert it to a JSON format. We will be returned with an object. We will name this object data. It's going to be readable to us. Data equals take our response object and use the JSON method to convert it to a JSON format. So let's print our data to see what we're working with. Let's say I look up the city of Miami. So we have one gigantic object. This is our weather data. We have coordinates, such as longitude and latitude, a weather description. Currently in Miami, there's broken clouds. There's an ID of the weather. This is the temperature, but it's in Kelvin. If we scroll all the way to the end, we are looking for an HTTP status code, which is named COD, short for code. 200 means that the response was successful. Depending on what this number is, we will display one of a few error messages. If our status code is 404, that means the city wasn't found. And there's many others. So 200 means that the request was successful. So let's write the following. If our data object at key of COD, if this is equal to 200, if the request was successful, then we will call the display weather method, self.displayWeather. But we do have to pass in our data. Now, temporarily, I'm just going to print our weather data. We'll do some more complex stuff later, but I just want to be sure that everything is working. So let's look up Los Angeles. So here's the weather in Los Angeles. There is currently broken clouds. And again, the status code is 200. The request was successful. I'll write an else statement for now. We will print our data. What if we can't find a city? For example, I will look up the city, blah, 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 and get the weather. So here's our weather data. We have an error code of 404 and a message of city not found. Let's do some exception handling in case we run into one of these status codes that's not 200. We can get rid of our else statement. What we'll do is enclose all of our dangerous code. That means any code that might cause an exception within a try block. We will try all of this code and handle any exceptions with an except block. There's two types of exceptions we're looking for. The first is an HTTP error. HTTP error is an exception raised by the request module when an HTTP request returns a status code that's 400 or 500. However, this exception is found within the request module that we've imported. So we can't simply just say except HTTP error. We first have to access the request module, then access exceptions. Then we can list the specific exception of HTTP error. We'll encounter this exception if the status code is between 400 and 500. And for now, I'll write pass. So there's one more step within our try block. If we're going to handle any HTTP errors, we have to raise an exception within our try block, because our try block by itself normally doesn't catch these. We will take our response object and call the raise4status method. This method will raise an exception if there's any HTTP errors. Normally, our try block doesn't do that, so we have to manually type this. There's another type of exception we'll catch, and that's the request exception. We'll add another block for except request exception. This is found within the request module. Requests, exceptions, request exception. With a request exception, this can be due to network problems, invalid URLs, exceptions of that nature. In case we run into one of those types of exceptions, we will execute this block of code, but for now, I'll write pass. We'll get back to it later. Going back to our except block where we handle any HTTP errors, let's use a match case statement. We need to get the status code of our response. I'll print that temporarily. Let's print our response object's status code and see what it is. Again, let's make up a city, get the weather. we have a status code of 404. That means the city wasn't found. Depending on what this number is, the status code, we'll use a match case statement. So we will match our response object's status code. The first case will be 400. That means there's a bad request. So let's print the following. Bad request. I'll add a new line character. Please check your input. We'll create a total of, I believe, 8 cases. We'll copy what we have. So we have 400, 401, 403, 404, that one we're familiar with, 500, 502, 503, 504. So for case 401, that means we're unauthorized. Maybe our API key isn't active yet. So let's say unauthorized, invalid API key. For 403, that means access is denied. It's forbidden. So let's print forbidden. Access is denied. 404 is for something that's not found. Not found. City not found. 500 is for an internal server error. Internal server error. Please try again later. 502 is for a bad gateway. Bad gateway. Invalid response from the server. .503 is for service unavailable. Service unavailable. Server is down. Then 504 is for a gateway timeout. Gateway timeout. No response from the server. In case there's any unexpected error, we can add a wildcard of an underscore. With our HTTP error, let's give it a name as HTTP error. And then we'll just print it. In case there are no matching cases, let's print the following. HTTP error occurred. I'll add a new line. Let's convert this to an F string. Add a placeholder. And then I will print our HTTP error. All right, let's do a test run. So in case we can't find our city, we should encounter a 404 error. Not found. City not found. Eventually, we will display this message within our app. But we know that it works. What if my API key is invalid? So I will take my API key, set it to be inactive. But it might take a few minutes to take effect. The status code of our response object should be 401. So this time I'm going to look up a city, I have an invalid API key, and I get that error message of unauthorized, invalid API key. Alright everybody, so I am on day 3 of working on and recording this topic. Over the course of the day, I thought of one change that I can make. We're going to add a few extra accept blocks. So we will accept access requests, access exceptions. We will handle any connection error exceptions. As well as any timeout exceptions. And any redirects. Too many redirects. So if we run into a connection error, let's say that our internet gets disconnected, well, we can print something. So let's print the following. Let's print connection error. I'll add a new line character. Check your internet connection. If we encounter a timeout, then we will print the following. We have a timeout error. The request timed out. If we have a too many redirects error, that M should be capital, by the way. Let's state too many redirects. Check the URL. And if there's anything else we don't anticipate, I'll give this exception a name of as rec error. And then we'll just print it. This is a last resort. I'll use an F string. Request error. I'll add a new line. I'll add a placeholder, then display our request error. So I'm actually going to turn off my internet. I'll see if I can get a connection error intentionally. So my internet is currently off. I will attempt to look up a city, get the weather, and we get a connection error. Check your internet connection. All right, my internet is connected again. Let's perform a test run. And we get the weather in Miami. Now what we're going to do is, if we have an error, we'll display the error message within the app and not within our console. So we're going to replace print with the call to our display error method. Let me zoom out a little bit. So replace print with self.display error. And we're passing in a message. So let's replace those. One thing I forgot to add, although it's not necessary, I'm going to add a colon after each initial message. I think it'll look better. You don't have to do this, but I'm OCD about the appearance. If we encounter one of these exceptions, we'll pass along a message to our display error method and display it within the app. Let's take our temperature label, self.temperature label, and set the text to be our message that we pass in. Let's do a test run. Let's look up a city that doesn't exist, get the weather. So we get that error message, not found, city not found. While we're within this method, I'm going to change the font size just so that it's a little bit smaller. So let's take our temperature label, self.temperature label. I'm just going to copy this because I'm lazy. I will call the setStyleSheet method and pass along a new property. Let's set the font size to 30 pixels. Let's look up North Pole. I don't think that's a city. Oh, I guess it is. Interesting. The North Pole is a city, I guess. Let's look up blah, blah, blah. Not found. City not found. Let's do another test. What if our API key is invalid? I'll just delete one of the digits. Let's look up Los Angeles. Unauthorized. Invalid API key. Let's change that back. Again, I will turn off my internet. Then look up Miami. Connection error. Check your internet connection. Alright, so we know that our exception handling works. Okay, now we're within the display weather method. We'll receive an object to represent our data. We have to get the temperature, but first I'm going to print our data. So let me zoom in a little bit. Let's look up Houston, Texas. I need the temperature. Within our data object, we are looking for a key of main, and that is right here. Main contains a dictionary with key value pairs. Once we've accessed main, we have to access temp to get the temperature, and this temperature is in Kelvin. We'll have to convert it to Celsius or Fahrenheit. It's your choice. So we need to extract this value. I will store it as a local variable. Temperature, let's say temperature underscore K for Kelvin, equals, take our data object, access the key of main, that's right here. Then we have to go one level deeper and get the temperature. The key is temp. Then give me the value at the key of temp. And that should return the current temperature. So to test it, let's print it. Let's print the temperature in Kelvin. So what is the weather in Houston, Texas? The temperature, that is. 309 Kelvin. Let's convert it to Celsius and Fahrenheit. Let's create temperature C if you want to use Celsius. If you would rather use Fahrenheit, you can skip this step. To convert from Kelvin to Celsius, we will take our temperature in Kelvin, subtract 273.15. Then for Fahrenheit, let's take temperature F for Fahrenheit equals, this is a little more complicated. Take our temperature in Kelvin times 9 divided by 5, subtract 459.67. Okay, so let's print the temperature in Celsius. Let's look up Houston. 36.46 degrees Celsius. Then in Fahrenheit, that would be 97.6 degrees Fahrenheit. That's pretty hot. All right, so once we have our temperature, let's change the temperature label. Self.temperature label, I'll just copy this. Then we will set the text. I'll use an F string. Add a placeholder. I'll use Fahrenheit, but feel free to use Celsius. Then I will add a degree symbol. With Windows, make sure numlock is on. Hold Alt, then on your numpad, type 0176 for a degree symbol. Then F for Fahrenheit. Let's look up Miami. Get the weather. And here's the temperature. 94.964. Now let's say I would like no digits after the decimal. I can add a format specifier. After our temperature, I'll add a colon, 0.0f to display no decimals. Let's try that again. I will look up Miami, get the weather. The current temperature in Fahrenheit is 95 degrees Fahrenheit. Now, here's one issue. Let's say we display an error, then display the weather. If we display an error, we're going to be changing the font size. So let's look up blah, 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 get the weather, city not found. Then let's look up Miami again, get the weather. And the font size is a lot smaller. So if we display the weather, let's reset the font size. We can really just copy this line. So within the display weather method, let's set the font size back to 75, what it was originally. Let's try that again. Let's look up a city that doesn't exist, get the weather, city not found. Then we'll look up a city that does exist, like Miami, and get the weather. 95 degrees Fahrenheit. Now let's get a description of the weather. We'll display that at the bottom. In the center, we'll display a picture or an emoji, but we'll handle that last. Now we need a description of the weather. Like, is it sunny? Is it cloudy? Is it raining? So after we calculate the temperature, so I'm going to print our data again. Let's look up Los Angeles. So currently it's 85 degrees Fahrenheit. So for the weather description, that is found at the key of weather. We're now within a list. At index 0 within our list, we'll look up the key of description, which states clear sky. So we will create a local variable of weather description equals access our data at the key of weather. There's layers to this. We're then within a list. And actually, it's a list with only one item in it. So at the index of 0, then at the key of description. That's going to return this description of clear sky. So we will take our description label, self.description label. Let me just copy it. This one right here. Then we will set the text. And then pass in our weather description. What is the weather description of Los Angeles? 86 degrees Fahrenheit, and there's a clear sky. Okay, now the last thing we're going to do is add an emoji. We'll add it right to the center between the temperature and the weather description. You don't necessarily have to, but I think it'll look cool. And that's a good enough reason. So let's create another method to handle that. We will define a method of getWeatherEmoji. Or a picture if you would rather use a picture. We don't need self necessarily. We're going to need a weather ID. This method isn't going to rely on any class data or instance data. We could make it a static method. I'll add a decorator of static method. In summary, a static method, we haven't covered these for a little bit. They belong to a class, but don't require any instance-specific data or any other methods. They're used as more of a utility tool. We're going to be passing in a weather ID and returning an emoji. I'm going to show you where we can find that weather ID. I'll use a print statement. I will print our data. Let's look up Miami again. That's the first thing that came to mind. Now, at the key of weather, there's a key of ID, and the value is a 3-digit number. I'll show you this chart. Depending on what this 3-digit number is, that corresponds to a certain group of weather. So the 200 range is a thunderstorm, 300 is a drizzle, 500 is rain, 600 is snow, 700 is atmosphere, like if there's a tornado or there's a volcanic eruption. 800 exactly is a clear sky. Anything that's 801 or above refers to clouds. So this ID is 803. We have broken clouds. Depending on what this ID is, I would like to return a certain emoji based on the weather. So we need this ID. I'll delete our print statement. We no longer need it. Let's say before our weather description, we will create a local variable of weather ID equals access our data object, then access the key of weather. The value at weather is a list, but this list only has one item in it, so we need the index of operator at 0, and then we will access the key of ID. The key is ID. So our weather ID is going to be a number, a 3-digit number. Okay, everybody, we're near the end. So after setting the temperature, we're going to set the emoji label. Self.emoji label and call the setText method. Within the setText method, we will call self.getWeatherEmoji method. This will return a string, an emoji within a string. But we have to pass in our weather ID. It's that 3-digit number. So now we are within our getWeatherEmoji method. Depending on the range of that 3-digit number, we will return one of a few emojis. We could use a match case statement. I think it's more complicated with the match case statement. We'll use else if statements for simplicity. So if our weather ID is greater than or equal to 200 and our weather ID is less than or equal to 232. Now we have two conditions here linked with the AND logical operator. There is a shortcut to this, and actually PyCharm is telling me that there is. We can simplify these expressions. Instead of two separate conditions, we can combine them into one. If 200 is less than or equal to our weather ID, and our weather ID is less than or equal to 232, if this one combined condition is true, then we will return an emoji. So to add an emoji on Windows, you can hold down the window key and press semicolon. So 200 to 232, that's for a thunderstorm. Depending on the font style of your IDE, some of these emojis might not display properly. You can always just copy them from someplace else. I think that's better. It's more colorful. Then else if 300 is less than or equal to our weather ID, and our weather ID is less than or equal to 321, this is for a partially cloudy sky. We will return some clouds, a partially cloudy sky. And again, I don't like that one, so let's use this one instead. Else if 500 is less than or equal to our weather ID, which is less than or equal to 531, we will return rain. That's better. 600 to 622. Else if 600 is less than or equal to our weather ID, which is less than or equal to 622, we will return snow. So 701 to 741 is mist or fog. Else if 701 is less than or equal to our weather ID, which is less than or equal to 741, we will return some mist or fog. 762 specifically is for ash, like from a volcano. So else if our weather ID is directly equal to 762, we will return, let's return a volcano. 771 is for a squall. That's a violent gust of wind. Else if our weather ID is directly equal to 771, we will return, let's return that, a violent gust of wind, a squall. 781 is for a tornado. Else if our weather ID is equal to 781, return a tornado. 800 exactly is for a clear sky. Else if our weather ID is equal to 800, return a sun emoji. Else if 801 is less than or equal to our weather ID, which is less than or equal to 804, we will return some clouds. Now, if there are no matches, let's return an empty string to not display anything. Okay, let's do a test run. Let's look up Miami. We get scattered clouds. It's 94 degrees. Los Angeles. Get the weather, we have a clear sky and a sun. Now, there's one fix we need to make. Let's say that I make up a city again. Blah, blah, blah. Get the weather. We should clear our emoji label and the weather description, but we still get that error message. So after we display our error within the display error method, after we set the text of the temperature label, let's take the emoji label, self.emoji label, and call the clear method to clear it. Then we have to do this with the description label, self.description label, and call the clear method. Now we should be able to clear it when we get an error. Okay, let's look up Houston. Get the weather. Few clouds, 98 degrees. Let's make up a city. Pizza City. Get the weather. Not found. City not found. And the emoji label and the weather description are cleared. Okay, what if I type in nothing? What happens? Let's get the weather. We have a bad request. Please check your input. That's if we have an HTTP status code of 400. We handled this exception. Bad request. All right, one last city. What about Paris? Let's get the weather. It is 68 degrees Fahrenheit, and there's light rain. All right, everybody, so that is a weather app that you can make using Python. Add it to your portfolio, and thanks for watching.